If you clicked on this video, it's probably because you want to learn reinforced concrete design using the software ProtaStructure. In this video, I will guide you through everything you need to know from receiving your architectural plan to completing the entire design process. I will walk you through structural framing, modeling, analysis, design, and detailing, as well as I will be showing you the key governing principles for columns, beams, and slab placement. For example, limit your column spacing to 6 meters to prevent beam failure, and keep your slab area under 30 meters square area to avoid deflection, and many more of these principles to come during the course of this video. I will also show you how to set up your project, define your structural element, choose the right material for your columns, beams, and slab, and ensure strength, stability, and cost effectiveness. I will also be showing you the difference between primary and secondary beam. I will teach you how to save cost by reducing moment, and I will explain on how to handle floating columns. Floating columns are those columns that do not start from the foundation level. I will also be exposing the governing principle behind them. You will learn the key safety measures you need to take to prevent building collapse, and how to implement proper quality assurance practice right from the design phase. Plus, I will dive deep into foundation design with focus on part-based footing, showing you all the necessary settings you need in ProtaStructure for perfect design, and when your footing reinforcement should be singly or doubly reinforced. This video will be packed with valuable tips and insights that are often missed in most of the paid courses. That means this video will be more valuable than most of the paid courses out there. So let's get started and unlock the full potential of ProtaStructure for your next reinforced concrete design. Miracle, okay, Richard. Welcome to SamGoz Engineering, and in this channel, I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe. This is the architectural plan we'll be working with, and here you'll get to learn so many things like the governing principle in column placement, in paneling, and also in beam arrangement. Here we have done the structural framing of this architectural plan, and we have that this is the ground floor and this is the first floor, and we have that this column, and this column will terminate at the ground floor. Look at them, they are the ones on lead. They will terminate at the ground floor. They will not continue at the first floor. Why these are the new columns that will continue from the first floor? Reason why they will terminate at the ground floor is because they are causing obstruction to this first floor. And to these new columns that we have introduced, which are on magenta, they are called floating columns. Floating columns are columns that did not start from the foundation. So here you get to learn the governing principle both in floating columns, in paneling, and also in beam arrangement. You also get to understand how this is being modeled in ProtaStructure, both the modeling, analysis phase, the design phase, and everything. Even the detailing. The detailing of this architectural plan will be done within the series of this video. So on getting your architectural plan for your architect, the first thing you do is to first of all copy out the architectural plan. The reason why we do copy out the architectural plan is because we'll be placing our column, our beam, and our slab. And two, during the placement, we'll be deleting some certain features of the architectural plan. So in case once we make mistake or we want to reference the original plan, we will still have the original plan. So that's the main reason why we normally copy out the architectural plan. So I'll zoom out. Once I zoom out, this is my architectural plan. So I'll copy out my architectural plan by highlighting it, and I'll now type CO. CO stands for copy. I'll click on enter. So I'll move this my architectural plan to how to place it here. So after copying out your architectural plan, the next thing that you have to do is to study your architectural plan. First, you study architectural plan. What's the building used for? Is it a residential building? Is it a commercial building? We have to know that if it's a residential building, the loading will be different from a commercial building because they will not be having the same dead load or life load applied to it. So we'll study the architectural building. Is it a residential building or is it a commercial building? Even if it's a residential building, you still study out your architectural plan, because in a residential building where we'll be having gym area at story 1, you know that the loading of that gym area slab will not be the same with other slabs. So these are the reasons why we do study our architectural plan. Another reason we do study our architectural plan is to know that it has a basement, because if our architectural plan has a basement, we should know that retaining wall in the basement floor will be a concrete wall. So these are the reasons why we do study our architectural plan. So when you are to studying your architectural plan, and also another reason why I study architectural plan is to know whether there are cantilever at the story one. So for example, look at this. These are toilet and bathroom. If you see, there is an offset backwards. But if you go to story one, if you can see, it's a straight line. So it's moving straight. That means we have a cantilever at story one. This is the cantilever. This is the cantilever. So these are part of the reason why we do. So these are part of the reason why we do study our architectural plan. So after studying your architectural plan, next thing to do is to delete the things that are not necessary to us as a structural engineer. You know, some of the architectural features in a building is not really necessary to us. For example, share furniture, kitchen furnitures, all these things, they are not necessary to us as a structural engineer. So if your architectural plan contains all those things, you delete them because they are not necessary to us as a structural engineer. Another things that are not necessary to us as a structural engineer is this dimension, this grid line. Don't worry, once we want to start, we'll create our own grid line. Then and also this dimension, they are not necessary to us as a structural engineer. So for that reason, I will delete them. So I'll just come, I'll highlight everything. I'll just highlight this. I'll just right click, then click on select similar. I'll click on select similar. Once I click on select similar, I will zoom out, hold my shift key, and then deselect the ones I don't want them to select. So I'll deselect this. So I'm left with only this. I'll click on E. E stands for erase. Enter. So if you can see now, my architectural plan is now clean, is now plain, like no obstruction and the rest. So I can easily work on this architectural plan. So I'll delete this sectioning because I don't also need it. So I would like to delete this because I don't think I will need it in my structural design. So after deleting the things that are not necessary to us as a structural engineer, the next thing is that we have to start placing our column. But first, before you place your column, you also have to place your before you place next thing is to start placing our columns and our grid line. But before you start placing your column and grid line, you first of all create a column and grid line layer. So let me type on, so to create this column and grid line layer, I'll type on layer. So you can easily type on layer, enter, or you locate layer on your menu bar. So I'll type on layer. So once this dialog box appear, I'll come and click on this new layer. So once I click on this new layer, this will appear. I would like to create a layer for grid line. So I'll just type grid. But since I'm doing a YouTube video, I'll just write grid U, which stands for, this U stands for YouTube. So I just want to, okay, let me just write grid YouTube. Sorry. So this is my grid line layer. So I'll like the color of my grid line layer to be, I'll like it to be this, to be this ash color. I'll click on OK. And I'll also like the line width to be at default. I'll also click on OK. So once I've created my grid line layer, next thing is to create my column layer. So to create my column layer, I'll say type column, but now I also like to type column YouTube because this is a YouTube video. So I like my column to be, let me just pick, let me pick this color. I'll click on OK, and I'll like the line width to be 0.5. You can choose any line width of your choice, but me I want 0.5, and then I'll now close. So since I've done this, next thing that I will do now is to first of all create a grid line on this my architectural plan. So to create a grid line, I'll first of all type L, enter. L stands for enter. Since my auto key is not turned up, I can turn my auto key on from here, or I'll just type Ctrl F8. My auto key will turn up. So I'll just do a line from here to here. But remember, before it's okay, I'll do a line from here to here. The reason for this line is because we want to place our grid line along this block wall. So I use this line to locate the center of this block wall. But first, before I start placing my grid line, I'll come and select the grid line that I just created now, which is grid YouTube. So I'll look for where I have grid YouTube and select my grid line layer. So look at it here. So I'm already on layer grid YouTube. So with this, to create your grid line, you type SL. SL stands for construction line. Enter. Then now type H. H stands for horizontal. Enter. So this is the reason why I created this straight line, to locate the center of this block wall. So I'll press it here. I'll click on escape. I'll highlight this and I'll click on E. Enter, delete it because it's no longer useful to me. So I'm having this line running through here. So what I'll do now is that I'll copy this grid line, CO, enter, copy it from one of the block edges. I'll copy it from this point. I'll place it here. I'll just be placing it on all the horizontal walls. I'll also anywhere I have a horizontal wall, I'll place it. This is my horizontal wall. I'll place it here. I will also place it here. Just anywhere you're seeing a horizontal wall, you place it here. I'll also place it here. And I'll also place it here. I'll also place it here. So sorry, Control Z stands for undo. I placed it wrongly. So I'll place it here. And I will also place it here. I'll also place it here. Let me check again whether I still have any other horizontal wall that I've not yet placed my grid line on. So now I think I've placed grid line on all the horizontal walls. Okay, look at this. This is a wall. This is a wall. So I'll also place it here. So right now I think I've placed grid line on all the horizontal wall. I'll do escape. So since I've created the horizontal grid line, next thing is to create the vertical grid line. So I'll click on L, enter. L stands for line. I'll do this to locate the center of this line. I'll then do SL. SL stands for construction line, enter. I'll do V. V stands for vertical, enter. Then I'll place it at the center of this line that I just created. I'll highlight E, enter to erase it. Then I'll copy this vertical grid line, CO. I'll copy from one of the wall edges, and then I'll be placing it on all my vertical walls. Anywhere I have vertical wall, I'll be placing it. Don't worry, the grid lines that are not necessary to us, later we will delete them during our structural framing. That's during our column placement and our beam and slab placement. We'll be deleting we'll delete the grid lines that are not necessary to us. So I'll place it on all my vertical walls. So I have a vertical wall here. I have a vertical wall here. I'll have, okay, it has already been placed here. I think, okay, I think I've placed in all my vertical walls. So with this now, I'll click on escape. If you can see, this is what we are having. So construction line is a line that runs throughout the whole AutoCAD interface. So I'll trim off all these lines. So to trim off all these lines, what I'll do, I'll click on rectangle. I'll just type REC, enter. I'll create a rectangle around this my architectural plan. So I'll create a rectangle around this my architectural plan. So this is what I want to have. Then I'll now highlight this rectangle. Then type TR, enter. Then I'll trim out this. Make sure that you highlight this rectangle, because if you do not highlight the rectangle, it will not really trim out everything. It will just trim out from here to here and stop here, that this architectural plan is blocking it. So I'll trim off this, and I'll also trim off this. I'll click on escape. Then I'll now come and highlight this my rectangle, E, enter, to erase it. So this is what I'm having now. This is my architectural plan, but I've already placed my grid line. Next thing is to start placing your column. So to place our column, I'll come here and select my column layer. So I save the column layer with column U2. So I'll locate it. I'll locate my column layer. So where is my, okay, this column, and I think column U2. So this is it. I'll click on it. So I'm on it now. So to create our column layer. So in this now, if I want to create column, I'll first of all type on rectangle REC to create a column. So I'll just draw a line here. What I'll have, I'll do at. You click on at 225, comma 225. So the reason why I'm using 225 by 225 is because 225 by 225 is the minimum column size that you can use. But in ProtaStructure, if it fails, then we'll not increase it. But to save cost, we'll go with the minimum column size, which is 225 by 225. And this is when you're having 9 inches block wall. But in a case where someone is having 6 inches block wall, which is 150 millimeter block wall, what that person will do, he will use a column size of 150 by 450, or you can use a cone size of at least minimum 150 by 350, but don't go beyond 350. So with this now, my column size will be 225 by 225. I will then click on enter. So this is my column now. So what I'll do now, I'll copy this column. Okay, but one thing I want to let you know is that structural framing is totally dependent on the engineer. But the thing is that the engineer needs to follow the guiding principle and the guiding rules and principle doing his structural framing. For example, I'll tell you the guiding principle. For example, column spacing should not be more than 6 meters. Another example is that slab area should not be more than 30 meters square area. Another example is that slab should not be more than 30 meters square area, and also others. But don't worry, during the course of this video, you understand all the governing principle relating to structural framing. So I'll copy this. If I copy this, I'll do CO, enter. So if you are placing your column, you try and place them at wall intersections, or you place them at wall intersection, and also place them at, so to remove, you place them at wall intersections. So to remove this auto key, I can come and click on this place, or I'll do Ctrl F8 to remove the auto key. So I'll place a column here. I'll place it at all the walls intersection. So one of the governing principle on column placement is that your column spacing should not be more than 6 meters. Yes, your column spacing should not be more than 6 meters. Reason for this is because you know that the maximum moment of a simply supported beam is WL square over 8. So if you look at that formula, you see that moment is directly proportional to rent. So that means, and to the rent in this formula is L square. And you know, once column spacing is more than 6 meters, for example, this is a column spacing. If this is more than 6 meters, is a beam that will connect this column to this column. So that means if column spacing should be more than 6 meters, what it implies that the beam is more than 6 meters, and maximum moment of a simply supported beam is WL square over 8. That means the more the rent, the more the moment. And what it implies is that the more the rent, the more the moment, and the more the reinforcement that you will be having. For example, if you go beyond 6 meters, you might be having, let me say, 5y16 or even 3y20 or even 2y25. So since because we don't really want all this larger reinforcement or too much number of reinforcement, that's why we advise that you should limit your column spacing to be below 6 meters. It's not that your column spacing can't go above 6 meters. It can go, but it requires some different things. For example, if it goes above 6 meters, it might require that you might be using higher number of reinforcement or higher steel grade, or it might be required that you be increasing the depth of your beam. So, but since this is a residential building, a duplex, so you just want to restrict ourselves to minimum minimum column spacing of 6 meters. So I'll place a column here at wall intersections. Anyway, I'm having wall intersection. I'll place my column there. I'll also place my column here. I'll be placing my column here. So this height is on. I'll place a column here. I'll place a column here. And okay, let me see. Then inside here, I'll place a column here. I'll also place a column here. And I'll also place a column here. Normally, I normally love placing column at the edges of my staircase, so it will be able to carry the stairs. So that's why I'm having these two columns here. So I also love to place a column here. Then okay, we need to have a column around here, so you can choose here or here. But if I choose this place, that means it's too close to this, so I won't like it. And if I choose here now, it's too close to this and it's too far away from this, so I would like to choose here. Then coming to this side, I would like to, okay, I can place it here. Or here. I can place it at this point or at this point, but I would like to place it at this point. Reason is because if I place it at this point, it will be too close to this. But if I place it at this point, I'll be having something like equal spacing. Let me escape. For example, if I place it here, it will be too close to this. For example, I might be having 2 meter here and I'll not be having 5 meter here. So I don't want that. I always like to have something of almost equal spacing. But if I place it here, I'll be having something like 3 meter, 3 meter. So for me, it's better, because if I do 2 meter, 5 meter, that means I'm having a bigger length. I'm having more rent, and you know that once there is a more rent, once you have more rent, what it implies that you'll be having higher moment. So I always like to limit my moment. So I will escape. Then I would also like to place a column here. So let me just copy this. Then enter. I'll copy this. Then I'll place a column here. So with this now, I think we are through with our column placement. But don't worry, after I will be checking whether we are obeying that principles of our column should not be more than 6 meters. One thing I forgot to tell is that if you are deleting things that are not necessary to us as a structural engineer, please don't delete your windows and your doors, because if you mistakenly delete your windows and your doors, you might mistakenly place a column at your window at one window position or at a door position. So if you are doing structural framing, don't delete windows or your door unless you are through with your column placement. So now we are through to our column placement. So let's check whether we are obeying that principle that minimum column size should not be more than 6 meters. So if we check from here to here, we are having 4.025. So for me is okay. So I'll leave it here. I want to go back to grid line. Where is my grid line? I want to go back to grid line here. So I'll click on it. Sorry. So I'm having 4.025 meter. So it's not more than 6 meters. So it's still okay for me. Then I'll check from here to here. I'm having 2.225 meters. So for me it's okay. I'll right click. Then check from here to here. I'm having 4.025. For me is okay. It's not more than 6 meters and it's not too small for me. So I'll leave it like that. I'll right click again. I'll check from here to here. I'm having 3.225 meters. So for me it's okay. It's not more than 6 meters. I'm having 2.85 meters. So for me, it's okay. Another thing in column placement is that if you are placing column, as a structural engineer, there are two things that are that are necessary to us as a structural engineer, which is one, safety. Safety is our priority. But then after safety is to save cost. If you check most of your buildings, if you check most of people that don't really have the knowledge of structural design, they might just come here and place a column here because they are seeing a block wall here. So if you are placing a column here, what you are just doing is that you are not being economical in your design, because these two columns will be able to carry the load coming from this slab. So if you are placing a column here, it's just that you are adding additional reinforcement. It's not that it's that useful. It's not that useful because these two columns will be able to carry it. So in your design, always put into consideration safety and economy. So let's continue with our spacing shakement to know whether it's above 6 meters. So I'll shake from here to here. So I'm having 3.225. So all these ones, they are okay. I'll also shake from, let me say, from here to here. I'm having 4 points, is okay, 4.02. I'll shake from, sorry, I made a mistake. I'll shake from this point to this point. I'm having 4.025. There is no need of checking here because there's in the textural pan they placed the column here. So even if it's more than, I must even if it's not more than or not, I must leave it because it is being placed for aesthetics. So I also click on this line. I'll shake from here to here. For me, it's not more than 6 meters, so it's okay. Definitely this one will not, definitely this will not be more than 6 meters, and this too will not be more than 6 meters. So I've checked my columns and I've seen that they are not more than 6 meters. So since this one is not more than 6 meters, that means this is not more than 6 meters, this is not more than 6 meters, and this is not more than 6 meters. But we can decide to shake from here to here. So I'm having, let me shake from here to this point. I'm having 5.25. So it's not more than 6 meters. So for me, it's okay. So since I'm through checking whether my column is more than 6 meters or not, so I'll delete this dimension because really they are not really necessary. I just dimension it to know whether my current spacing is more than 6 meters or not. So I'll delete the whole dimension because they are not useful to me. I'll click on A, enter. So after my column placement, the next thing, yeah, let's shake something. I told you about safety and economy. So since, let's take whether our columns, whether they are too close or they are too far away from each other. So look at this. I'm seeing, so let me shake from here to here. I'm having 4.40. That's 4.4 meters. So for me, this 4.4 meter will be able to carry this load coming from this slab and this load coming from this side, and also this beam, because this beam will be acting as a point load on this beam. So since this is 4.4 meters, for me, I don't really see the need of this column. So in order to save cost, I'll delete this column because this is 4.4 meters, so it's too close. But another engineer can decide to leave it. Yeah, so it dependent on the engineer. It is dependent on the engineer. But me, I don't want to leave it. I want to remove it. So to save cost, because this is 4.4 meters, and I know I say that it should not be more than 6 meters. So 4.4 meters is too small. Is too small. So it will be able to carry this load on the load coming from this side and the load coming from this side, and also this point load. So to save cost, I will remove this column. So let me also shake. Let me look at places that I have column jam packed. So look at this place. So let me also shake this area again. So I'll shake from here to here. So I'm having 3.375 meters. So I don't really see the need of this column. So to save cost, I'll remove it because I told you safety first, then economy second. So to save cost, I'll remove this column. Yeah, because it's too close, 3.375 meters. So it's too close. I'll just click on it, click on E, enter. So I'll delete it and also delete this dimension. So I'll shake from anyway again. I'm having a column jam packed. This one I would like to leave it. Okay, let me shake the length between here to here. So I'm having from here to here. I'm having 5.25. But me, I would like to. I just want to leave this column. I don't know why, but I just feel like leaving the column. So I'll just leave this column. But another engineer can decide to remove it. So that's why I said social framing or general arrangement drawing is totally dependent on the engineer. So since I'm through with my column placement, the next thing is to carry out my beam placement or paneling. Let me do paneling. Paneling is placing your slab, determine how your slab will run. So in paneling, one thing you have to know is that paneling, your slab area should not be more than 30 meters square area. Reason is because once your slab area is more than 30 meters square area, we'll be having deflection on that slab. So to avoid that deflection, we'll limit our slab area to be less than 30 meters square area. So you have to take this, you have to note this principle. And two, don't forget, you can get this architectural plan on the description on my seller store. The link is at the description below. That this architectural plan, you can get it on my seller store and practice on your own, because practice make perfect. Practice make perfect. And one thing that comes with this architectural plan is that I've done the structural detailing for you. So in case you are doing, in case you are doing the modeling and everything, if you enter detailing and you need guide on anything, you can refer to this structural detailing and get what you want. So you can get the architectural CAD file of this house, of this duplex on my Stellar store, and to the link is on the description below, or I've pinned it on the comment section. So get and practice on your own. You know, practice makes perfect. And to, if you want to master anything, mastery comes from repetition. If you want to master anything, is by doing it again and again and again. So I'll click on this, I'll delete this. It's not necessary, I don't want it. So let's continue. So paneling, we say that paneling should not be more than 30 meter square area. So if your paneling should be more than 30 meter square area, what you do is that you either increase the depth from 150 to 175, or you break that panel with a beam. Don't worry, let's continue. I will show you the example. So I want here to here, I want this whole place to be one panel. So that's what I want. So since I want this whole place to be one panel, I'll delete this. I'll delete this. Enter. I will also delete this, and I will also delete this. Enter. I want this whole place to be one panel. I'll also delete this. I'll delete this setting. So I will just click on this point. I'll do ES. ES stands for extend. I'll click on this line, extend this line. Then I'll come again, click on this line, and click on this line. Then I'll erase. Then okay, I will highlight this column, then click on ES, which stands for extend. I will extend this line and also extend this line. So this is not my panel. So this is my first panel. I would also like the whole of this area to be my panel. So if I'm having this whole area to be my panel, I have to delete this block wall. So I'll just delete this, and also I will also delete this, and also delete this. I would like to delete this and this, and then do enter. So I've deleted everything. So I'll click on this column. I'll do ES, enter. So I'll extend this line, extend this line, extend this line, but I've mistakenly deleted this line, so no problem. Let me just delete this one to enter. Then I'll just copy this line, enter. Copy this line and then place it here. So I would also like here to be one panel again. So I'll delete everything here, and I'll also delete everything here. Enter. Then I'll click on this column. I'll do ES, enter, which stands for extend. I'll extend, then I'll extend, and I'll extend. So I'll escape, then do another ES, enter, extend this and extend this. So this is my first panel, second panel, and third panel. Remember what we said, our area should not be more than 30 meters square. So I'll check the area from here to here. I'm having 4.02 meters. I'm check from here to here. I'm having 3.22. So if you can see, let's just do 4 times, let me say 4 times 3. 4 times 3 is 12. So you see, even if it's 4 times 4, 16, it's not even up to 30 meters square area. So we are good to go. Let me also check from here to here. So I'm having that from here to here is still 4.025. So you see the same thing is less than 30 meters square area. So I would like the whole of here to be one panel. So since I want the whole of here to be one panel, so delete I'll delete everything here. I like to delete everything here. I'll do enter. I will also click on this, click on this, click on this, do, and also click on this, and also I like this enter. So I'll delete everything. So I like the whole of here to be one panel. Let me also delete these windows. So I'll click on enter. Then I'll click on this line, and on this line I'll do ES, enter. I'll extend this and also extend this. So I'll also, okay, let me delete this. Let me also delete these ones. Then I'll do enter. I'll click on this block wall. I'll do ES, enter. So I'll extend this, and I'll also extend this. So let me also click on this block wall, ES, enter. I will extend this, and I'll also extend this. So this is one panel, one panel, one panel, and this is another panel. So let's check what we have said. Is it more than 30 meters square area? So we are having here to be 2.62. So I'm having from here to here. So if you can see, it's not more than, so let me say 4 times 3 is 12. It's not still more than 30 meters square area. So we are good to go. So I would like it to be one panel again. So I'll delete this, and I will also delete this. I'll click on enter. Then I'll click on this column ES to extend my line. I'll extend this. I'll also extend this, and I'll extend this, extend this, and also extend this. So this is another panel. Then I would like this whole sitting room to be another panel. So I'll click on this, and also click on this, and I will click on this, and I will come here, click on this, and I will also come here, click on delete this, and also come and delete this. I'll click on E, enter. Hey, I made a mistake. Oh, sorry. So I'll click on E, enter to delete this. I also click on E, I also highlight this, and I also come and highlight this. E, enter to delete this. So this bar I also like to delete everything relating to this bar. So I'll delete this. I'll also delete this, and also delete this E. Sorry, not R, E, enter. Then I would like to delete this E, enter. So this is, I want the whole of here to be one panel. So I'll click on this column, ESC, enter. I will extend this and also extend this. I will extend this and also extend this. So I'm having, okay, then this E, enter. Then I'll do ESC, enter. I will extend this and also extend this. Then I want a beam to run from here downward. So what I'll just do is that I will click on this MA to match property. To match property, I will match property of this to this. So this is what I'm having. Then I want to draw this line back. I'll stop it here. So what I'll do now, I'll click on this line. I'll click on this line and do ESC, enter, and then extend this and extend this. So this is a sitting room. So let's check whether it is more than 30 meters square area. So we are doing from, let's say, from here to here 3.8, and we're having from here to here we're having 5 meters. So 5 times 3.8 is 19. So it's no more than 30 meters square area. So we are still good to go. So coming to this point, how will our beam run? Are we going to have a beam separate from here, then run like this, run like this? So to determine how this beam will run here, let's go to the second floor and know what we're having at the story one. Okay, so this is the point, like this point, look at it here. So if you see now a column, we're having wall load straight. So that means I would like this column, I would like this beam to run straight, so to be able to carry that wall load. These are part of the reason why I say you should study architectural plan. So for that reason, I will delete this, I will delete this, and I'll also delete this, delete this, delete this. I'll just do like this. I'll, yeah, I will do like this, then delete this and delete this. Click on E, enter. So this is what I'm having now. Then let me click on, let me match property, MA, enter. This is the window. This is that my beam. I'll click on this one, ESC, enter. So I will run it through. So at this point now, a beam will run from here, here, and here. So let me just match property, MA. I'll match the property, match property, match property, match property, match property, match property. So right now we are through with our column placement, and we are through with our social framing. So let me delete all these things because they are not necessary to us. I'll also delete this E, enter. So coming to the, okay, look at, coming to this point now, let's study this case. We have a column placed here. So let me check out the dimension, check the dimension, because I would like to show you something from just this. So I'm having 2.225 here. Let me repeat this. I'm having from here to here, I'm having 5.25. So if you look at this critically, I'm having 2.225 and 5.225. So this beam that is 5.225 is carrying a point load here. Look at, it's carrying a point through here. But don't worry, before I explain this thing, this is a staircase, Abi. So me, I normally like at the end of a staircase, let a beam, like, you know, this would be a void. So I like a beam to carry this slab here. So to introduce that beam, I'll just come here and do MA to match property. I'll match here the property, then I'll now offset OFF. I'll offset 225 from this point. So this is a beam. Yes, so this is my beam now. So this beam now, if you look now, we don't have any grid line on this beam. So I'll place a grid line here. I'll just do arrow, enter. I'll do from here, since my auto key is not turned on, I'll do Control F8 to turn on my auto key. So I'll turn on my auto key. So let me also extend it to this point. So I'll then do CO, enter. I'll copy this grid, allocate the center. So this is it. Then I will now delete this E, enter. So I've placed a grid line on this. The reason why I placed a grid line along this beam is because so I'll be able to dictate this beam in ProtaStructure. So that's why I placed a grid line here. So let's continue what we are saying before. So if you look at now, we're having 2.225 here. 5.25, and this beam now that is 5.25 is carrying a point load, and two, is carrying a point load. That point load is this beam, and two, this beam now is carrying a load from this slab, a load from this slab, and transferring that load to this beam and to this column. So a point load from this beam, and also a point load from this beam. Not just that the length is 5.2 meters, it's kind of a point load from this beam and from this beam. So me, and look at this one now. This one is just 2.225 meters, no point load, just kind of only slab. So for that reason, I would like to move this CO enter, because if I allow this thing to be like this, in ProtaStructure, I'll be having higher reinforcement, because it's not just that the length is much, it's carrying point load. So I like to move this, because this is just 2.225, and I like to make the length to be almost equal, so that the load will be distributed. So I like to move this to this point. Yeah, so for that reason, I'll now delete this E, enter. Yes, sorry, I'll not delete this E, enter. So I like to have this, I like this column to be placed here, so that if you okay, let's now check the our new length, our new column spacing. So I'm having from here to here, which, sorry, I made a mistake, I not place it well. So let me repeat it. So I'm having from here to here, which is 4.025, and also from here to here, which is 3. So if you see, the is almost of equal length now. And two, this one is not really carrying a point load, this one is just carrying a small point load, but there is a point load carrying a beam carrying, let me say, small load of a slab, that's carrying a small slab. So for me, this is okay, instead of having a column placed here. So these are the part of the things you as a structural engineer need to put into consideration while doing your structural framing. So right now we are through with everything concerning our structural framing. So since we are through, next thing to do is to superimpose. What do you mean by superimpose? Superimpose means,
If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group, so that more people will get to see this and they will also learn alongside you.
superimpose is just the process whereby we copy these whole columns, that the whole column that is here, and place it on this story one, to know whether we'll be having any column popping off on the slab on getting to story one. Don't worry, you see what we mean by superimposing. So we'll just highlight this, we'll just right click on select similar. So click on select similar, and now do C O enter. If you are copying, make sure you copy from staircase. Sorry, C O enter. If you are copying, make sure you copy from staircase, because staircase is a point, is a staircase will be the same both as story one, story two, to the number of stories that we are having. So I'll copy from staircase, and I will place it here. So this is what we'll be having. So if you look at now, this column will stop at ground floor. This one too will stop at ground floor, because this one is popping up, is showing on the room. This one will stop at ground floor. It will block this door, and this will stop at ground floor. So let me just turn them to red, so that if I see them, I'll know they are stopping at the ground floor. This one will not stop on the ground floor because it's still inside the wall. So this one too, this one will stop at the ground floor. Yes, this one will stop at the ground floor. So let me change the color to red. So since I've gotten one that's up and the ground floor, that means this column still has to continue. So what I'll do now is that I'll copy this column, CO, enter. So I'll place a new column here. Like this one will stop at the ground floor, then this one will now continue as story one. I'll also place a new column here, and coming to this point. Okay, let me just coming to this point, CO, enter. I'll copy this and place a new column here. So these are the new column that will emerge from story one. So I'll highlight it, because there are new column that will emerge from story one. So I would like to change the color to magenta, so that once I'm seeing it, I'll know that this one will stop at the ground floor, and then this one will continue at story one. So coming to this one will start at ground floor. But if you check our architectural plan, you see this column do not continue. It did not continue. So this is a part of the reason why we say we should study your architectural plan. And to don't forget, you need to practice, because practice makes perfect. To repetition is to master anything is through repetition. So if you want to master the art of structural design, it's through repetition. I know how I got good in structural design. I know how I was practicing on daily basis. So it's better that you just set out, let me say, 30 minutes set aside for structural design, than just in a week you have, let me say, 3 hours every Saturday set out for structural design. So it's better you be practicing daily, because practice makes perfect. Even if it's 30 minutes per day, make sure you do something on structural design. Even if it's not structural design, learn a new thing or watch a video on structural design. It will help increase your knowledge. So this is what we're having now. So next thing I would like to do now is, for example, we have seen that we'll be having cantilevers on our second floor, sorry, on our story one. So, but we don't really know where those cantilevers are here. So, what I will do to for easily modeling, or so for easy to model this in easily on ProtaStructure, I will highlight the boundaries of this story one. Don't worry. Once I'm through now, you understand what I'm doing. Once I'm through, you really, really understand what I'm doing. I just want to highlight the whole boundary of this story one. Reason is just to know where I'm having cantilever. Region is just to know the places that I'll be having cantilever. So I want to highlight the boundaries. Don't worry, you understand. Once I'm through with this now, you understand what I mean by highlighting the boundaries. So, and I'll be having this. So what I'll do, I'll just do CO to copy. So I'll copy this, I'll place it here. Then I'll do ES. ES stands for extend. I'll extend this to match up, extend this to match up, extend this to match up. Why is not matching? Extend this, extend this, extend this. I'll also extend this, and also don't worry, we're almost through with this video. I'll also extend this. We're almost through with the structural framing. I'll also take this back. I like to match property MA, enter. So I'm having this, I'm also having this. So this is it now. So I would like to make this thing a block element. I'll just click on block element. Then I'm just type wall. Let me just save it with, I made a mistake. Let me just save it with wall. I'll just click on okay. Okay, sorry. Okay, it's not a block element. Block element, what it means is just to make it a one member, to make it one member. So I'll just click on the CO and enter. So I'll copy this. I'll copy it. We know that this is the staircase region. So I'll copy from this staircase region and place it here. So you can okay. I want to turn the color. I want to change the color of this to. Let me change the color to. Let me say this color. Okay, let's just see it like that. So this is what we're having. So if you can see now, that means we're having cantilever at this point, at this point, and at this point, and we're also having cantilever at this point and at this point. Reason why I created this cantilever is so that we can easily model it on ProtaStructure. Don't worry, once we get to ProtaStructure, you see the reason, and you see the reason for this cantilever. You see how easy it will be for us to model it. So at this point, I would like to delete the grid lines that are not necessary to us, or the grid lines that we did not use. So we did not use this. Okay, sorry, we use this one. We use this grid line. We use this grid line. We did not use this. We used this. We did not use it. No, we did not use it. We did not use this grid line. We did not use this grid line. We used and we did not use this. We used. So I think on E, enter. So at this point now, we are through with our drawing. So what to do now is to save this drawing at origin. Reason for saving this drawing at origin is because in ProtaStructure only recognize files saved at origin. So we'll save this drawing at origin. So how are we going to locate our origin? You just type L. L stands for line, enter. I'll do 0, 0, enter. So let me just paste it here. Let me just paste this right here. So this is my origin. This is my origin. So what I'll do now? Is that I'll come here now and copy this drawing. CO, enter. I want to save it at origin. So I'll copy this drawing. And I'll save it here. So this is my origin. I'll click on E, enter. Then to save it at origin, I'll click on W. W stands, okay, first of all, I'll highlight this, click on W. W stands for web block. That's to save only this file or only this drawing. I'll click on enter. Then I'll come and click here and choose millimeter. Then I'll now click on this three dots. So I'll allow it to open. I would like to save this on my desktop, and ProtaStructure only recognize DSX file, DSF file. So I'll click on DSF file. Then I will name it. I want to name it with YouTube. Let me just select it YouTube. Let me just say YouTube 1. Let me just have it with YouTube 1. So I want to name it with this. So I'll click on save. Then I'll now click on OK. So with this now, we have saved our DSX file. So let me minimize. We save this on our desktop. So let me minimize to locate it on my desktop. So this is it on my desktop. So let me click on it again. Let me double click on it. So if you double click on it, it will open. So if it will open, you'll be seeing it like this. But don't panic. What you just need to do is just to turn on your line width. You just type line. You just click on line width. Just click on display line width. So as you can see, it's out now. So this is it. So this is the DSF file that we saved. If you can see, it is DSF file. So we have come to the end of this video. In part 2, we'll open this DSF file in ProtaStructure and we'll model it, and we'll also do our design. But don't forget, you can get the CAD file of this architectural plan in the description below, or it is pinned at the comment section. And to don't also forget, it comes with the structural detailing, like I've done the structural detailing. So once you are after your design and everything, once you enter detailing, you can easily reference it once you make any mistake for correction and the rest. So the CAD file comes with the architectural plan and the structural detailing. Once I open the software ProtaStructure, I will click on new project. So I'll click on new project and I'll allow it to load. So I want to name this project. I want to use the name you I want to use the name YouTube. Let me just call it YouTube 1. Let me use the name YouTube 1. And then you now select the code that you want to use. And in this video, I'll be using United Kingdom. That's Euro code. This is the code I'll be using in this video. So I'll click on OK. And this is the ProtaStructure interface. So right now, all we'll be doing is to import our structural framing that we did in AutoCAD into this ProtaStructure software. So first, we'll go to building setout. Once you go to building setout, you click it. You now come under external reference drawing. You click external reference drawing. A diagram box will appear. Then you now click on add DSF. You know that we saved our file as DSF file because ProtaStructure only recognized DSF file. So once you have gotten our file, we will locate it. We saved it on our desktop. You click your desktop. So this is our file. So I'll click on it. Once I click on it, I'll then click on open and then allow it to load. So it has loaded. But if you can see, you're not seeing anything here. So I'll click on this active button. So once I check this active, this will appear. Then if I want to turn on my color, I'll turn on my color from here. I can increase the capacity of the color lightening or decrease it from here. Look at it, I've decreased it. This increasing it a little bit, it will appear here, but I want to leave it at maximum. Then since once I've imported my DSF file, next thing to do is to go and import my grid line and my column. So importing grid line and column, I'll click on this place named import. So I'll click on it. Once I click on it, a dialog box will appear. So this is my grid. So I saved my grid line as grid YouTube. I'll check it and then click on OK. Then why my column? I saved it as column YouTube. So I'll deselect this and then leave this one. I'll click on OK. So once you have selected your grid line and your column, you come and click here, import. So once you click on import, you allow it to import. So it's importing. So let's wait for it. It has imported. So we now click on close. So right now we also click on OK. So it has imported. So another thing, the next thing to do now is to rename this axis, but you can only rename this axis if you are using ProtaStructure 2025. So to rename this axis, I'll come to this place review and I'll now come and select relabel members. I'll click on it and then I'll check axis because I want to relabel axis. I'll come here, move it to 1. I'll then click on OK. So let's watch. As you can see now, it's now 1 2 3 4 and ABC. So we have renamed our axis. After renaming your axis, next thing to do is to insert your beam. So we can easily insert our beam by we'll come to model, then we'll now come and click on beam, then we'll click on normal beam. So at this point we want to insert our beam. Then they're asking us what is the breadth we want to use. So in this case, I want to use the width of my block wall, which is 225. So I'll just type 225. So this is the width I would like my beam to be. That's the width of my block wall. Then I'll now come to this space, height, which is the depth of my block wall. So remember, our aim is to save cost. So in saving cost, we'll first of all go with the minimum beam depth. And to the minimum beam depth we have is 300 millimeter. Then in that minimum beam depth, we now have minimum beam depth is 300, then plus the depth of slab. So minimum beam depth, which is 300, plus the depth of slab, which is 150. So 300 plus 150 will give us 450. So here I'll be using the depth of my slab to be 450. It is gotten from minimum beam depth plus the depth of your slab, and we know that minimum beam depth is 300. Don't forget the reason why we are using minimum beam depth, that is 300 plus 150 giving us 450, and minimum column size, that is 225 by 225 is for us to save cost, and that is what the code specify too as the minimum size. So but this is what we'll be using. But if it fails in cost of our design, if it fails in cost of our design, therefore we will not increase it. But to save cost, we will be using minimum. Then if it now fails during design, then we will not increase it. If the beam fails, we increase the beam depth. If the column fails, we will not increase the size of column. So don't forget, our aim is to save cost, why safety is still our priority.
So right now, I'll then come and connect all my beams. So I'll be having this, but I want to run it through. I'll also run it through from here. I'll click on escape and then run from here to here. Then I will also drop it here. So this is a cantilever. If you can see now, you'll be seeing this arrow sign. This arrow sign indicates a cantilever. So this is a cantilever. So this small beam now is a cantilever that will be carrying this beam. So this small beam and this small beam, they will be cantilevers that will be carrying this beam. So but let's continue. You still get to understand. So I'm having from here to here. I'll click on it. Then I'll join it to this place. So these two small beams, they will be carrying this beam. So I'm also having from here to here. Okay, let me show you something now. Let me drop this here. As you see, if you can see now, I'm having that this beam is a cantilever, but this beam, I don't want it to be a cantilever. So what I will do now is that I'll just highlight this and delete it. I'll just click on delete. So I'll double click on this one to bring out this property. I'll first of all connect a beam to this. So I'm having this now. Then I'll now come and connect this. If you can see now, that arrow sign is no longer showing. Reason is because we have now made this beam a secondary beam. Look at this beam now is a primary beam. The reason why it's called a primary beam is because it is connecting two columns. It is resting on two columns. Why this is resting on a column and on a beam. So this is our primary beam and this is our secondary beam. And to this secondary beam is acting as a point load to this secondary beam is acting as a point load to this primary beam. So first, in your modeling, you make sure you first of all connect the primary beams first. Then you now connect this secondary beam. If you connect the secondary beams first, that cantilever sign will be showing you that it is a cantilever. So first of all, connect your primary beam. So I've explained the difference between primary beam and a secondary beam. So let's continue. If you can see now, I did this one first from here to here, which is primary beam. As me, I did this one first. That means that cantilever sign will be showing. So but I don't want it. I'll connect it. Okay, let's use it here. If you see now, I've seen that cantilever sign. Reason is because this thing is serving as a cantilever. But if I first of all connect this, then I'll not allow this one to rest on it. But remember, if I'm connecting this one is not a primary beam, because it is not connecting two columns. It is resting on this beam. So this is a secondary beam, and this too is a secondary beam. But the difference is that this secondary beam is carrying this secondary beam. So in this case, for these two beams, this is my primary beam and this is my secondary beam. Why for these two beams, this one is my secondary beam, why this is my primary beam. Hope you are understanding. So let me do Ctrl Z to remove this. Then I'll double click on this to bring out its property. I'll first of all connect from here to here. So and I'll also connect from here to here. Then I will connect from here to my goal is just to connect all my columns. Then I'll also connect from here to here, and I'll also connect from here to here, and I have this beam connect from here to here. This beam will be carrying this slab. Then okay, I have this beam connect from here to here. Yes, I think we have to do. Okay, see here, I'll connect from here to here. So okay, look at this. I'll also connect from here to here. So right now we have modeled all our beams. So yes, we are through. We have modeled all our beams. Next thing is to insert our slab. So I will escape. So next thing is to insert our slab. So I'll come to modeling and then click on slab. So once I click on slab, they are telling me to define load case or to assign load case. I'll click on yes. So once I click on yes, I'll just come here and click on loading generator. So it will generate the road for me automatically. So in this vertical road, leave all these things as default. You see, they are all gotten from the code. So leave them as default. Then in terms of this horizontal road, assuming I'm having, so I'll only check this wind road if my
if the height of my building is above 10 meters. So if the height of my building is above 10 meters, that means it will be affected by wind. But since this is a duplex, that's it will be three. The first floor is 3 meter and the ground floor is 3 meter. So it's not up to 10 meter. It's not, the building height is not up to 10 meter. So therefore, I will not shake this wind load because it won't be affected by a wind load. So I'll just since the vertical ones, leave it at the first, then the horizontal one, if you're having wind load, you check it. Then I'll then come here and then click on OK. So it will automatically generate the load for me. I'll then click on OK. So a dialog box will appear here. So once my dialog box appear, then the height of my slab, I would like to use 150. I would like to use 150 as the height of my slab. Relative level, leave it at 0. Then under loading, we'll come input our dead load. So dead load is gotten from partition load. Dead load is equal to partition load plus finishing load. So partition load is within the range of 0.5 to 1, while finishing load is within the range of 1 to 1.5. Yes, do you understand? Finishing load is within the range of 1 to 1.5, while partition load is within the range of 0.5 to 1. But in this case, I would like to be using finishing load to be 1 and partition load to be 0.5. So if you add both of them, you'll be having 1.5. So this now is the self weight of slab. So the software have automatically calculated the self weight of our slab for us, and the self weight is gotten by the unit weight of concrete times the depth of your slab. So the software have done that automatically for us. So this is this. Remember, finishing load is just something like ties, terrazzo, and the rest. Then I'll come and right click on this impose load. So I'm designing for a general domestic use building, that's a residential house. I'll click on this. Then roof load, I'll leave it because this is the country where I am. We don't have all this adverse weather, so I'll leave the roof load at default. I'll leave it at 0 because there is no snow here and all this. But if I'm in a country where I'm having all this through, I'll likely increase my roof load. So with this now, I'll then come and click here to input my slab, click input my slab, click input my slab. I'll be clicking, and also I'll be clicking. So it not appear here, I'll click here. But don't forget, this is a staircase vision, so we won't apply any slab here. So after this, I will close this. So the next thing now is to hinge our members, to hinge our beam. So now listen, let's explain this. Let me explain this way now. If you can remember, summation of moment at any point is equal to 0. If you can remember that, summation of moment at any point is equal to 0. So let me come to this point now. At this point now, we'll be having this moment going in this direction. We'll be having a moment. We'll be having a moment going in this direction, and this side will be having a moment going in this direction. So one will be positive and the other one will be negative. Something like we'll be having positive 30 kilonewton here, and this side we're having negative 30 kilonewton. So if you sum both of them, since one is positive and the other one is negative, if you sum both of them, you'll be having 0. Yes, because the summation of moment at any point is equal to 0. So the same thing with here. There is a moment like this. That's if you can remember your social analysis. That's in your university level. We're having a moment like this and also a moment like this. One of the moments will be positive and the other one will be negative. For example, positive 20 and negative 20. So if you sum both of them will give you 0, because there is a rule that says that the summation of moment at any point will give you 0. I say summation, I did not say moment at any point. Moment at any point will not be 0, but the summation of the moment is equal to 0. Then coming to this point now, we are only having one moment at this side. If you see now, this is not a continuous beam, like this beam did not continue from this side, so therefore there is no moment here. So since you're having only one moment here, and remember the rule that says summation of moment is equal to 0, that means this moment, the moment here, is automatically equal to 0. I don't know whether you understand what I'm saying. I said here now, we'll have, let me say for example, we'll be having a moment here, but we should have a moment here and a moment in this direction. But in this case, we are only having beam in this direction, but there is no beam in this direction. So what it means that the summation of moment at this point is equal to 0. So the moment here that we have here, that it means that it is 0. Why here now the moment we have here can be 30, why the one we'll be having here will not be negative 30? If you sum both of them, it will give you 0. Why at this point we don't have any moment here, and the moment we'll be having here will be 0, because the summation of moment at any point is equal to 0. So for that reason, ProtaStructure doesn't know that here like there is no moment here. Like it's taking that the moment at this point is not equal to zero. So we now have to tell ProtaStructure see that the moment here is equal to zero. The moment also at this point is also equal to zero. So by doing that, for example, look at it. This is I n, this is I n, and this is j n. So I will just come click on this beam. I will right click and I will say I will come to update beam end condition, and I'll say hinge at left end, which is I end. I'll click on it. I'll now click on apply to the selected beam. You see now, if you can see now, you'll be seeing this red dot here. So what it implies is that we have hinged this member. One of the advantage of hinging your member is that it will help you save cost. Remember, I told you as a structural engineer, first thing is safety, second is economy. So you have to be economical in what you are doing. Don't waste your client's money. If you don't hinge this point now, you'll be having higher reinforcement, because if you do not hinge here, ProtaStructure will not recognize that the summation of moment here is equal to zero. ProtaStructure will take it that there is a moment here, and you know that the more the moment, the more the reinforcement. So if there is a moment here, ProtaStructure will counter for the moment here by providing more reinforcement. I don't know whether you understand what I'm saying. So you have to hinge here so that ProtaStructure will know that here is hinge and will not provide any additional reinforcement here. But don't hinge this point, because the summation of moment here is equal to zero, but the moment here is not equal to zero. It is the summation that is equal to zero, not the moment. Here now the summation is equal to zero, and also the moment is equal to zero, because if you sum up the moment here, it will give you zero, and two, there is only one moment here, therefore that one moment will be given us zero. I don't know whether I've been able to do justice to this explanation. So we know that in drawing this beam now, if you want to draw this beam now, you'll be having it will be going like this. It will come here, it will go up, which is high moment, it will also come down, it will go up, hugging moment, it will also come down, then it will now come and terminate here, which is there. If you can remember your university days when you are drawing bending moment diagram, the bending moment diagram will go like this: go up, hugging moment, come down, sagging moment, go up, hugging moment, come down, sagging moment, then terminate at zero. I hope and I believe that I've been able to do justice today. So therefore, I'll be applying hinge to all these things. So this one now, I'll be hinging here, and I'll be hinging this end. And for this beam now, I'll be hinging this end and this end, because this is a simply supported beam. So the moment in both directions is equal to zero. So I'll come here and click on hinge both end. I'll come here and I'll click on apply. So I will just select everything. I want to select all the simply supported beams. That is the beams that I'll be hinging both directions. So let me select this one again. This is a simply supported beam. You hold your control key, you select this. This is a simply supported beam. You select this. This is a simply supported beam. You select this. This is a simply supported beam. You select this. I want to select all the simply supported beam. So I will hinge it at once, not hinging one after the other. Sorry, this is not a simply supported beam. So I'll hold my control key and I'll hold my control key and deselect it again. So I want to select all my simply supported beam. This one is not a simply supported beam. It is continuous until it's kind of a cantilever. So if it's kind of a cantilever, please don't hinge it. Don't hinge a cantilever, because we know that cantilever will be having a hugging moment. Yes, it will be having it will be having reinforcement at the top. So don't hinge a cantilever. So I'll just, this is a simply supported beam, I'll hinge it, This is a simply supported beam, I'll also hinge it. This is a simply supported beam, I'll also hinge it. I don't know whether I'm through with all the simply supported beam that I have here. Let's check here. No, this is not a simply supported beam, not a simple, not okay, yes. Then yes, sorry, this is also a simply supported beam. Yes, this is a cantilever. This one is not a cantilever. Is this that is a cantilever, and this that is a cantilever. So this is a simply supported beam. No, it's not a simple. Yes, but we have hinged it. No, so yes, so we'll now right click, then now click on come to update beam end condition. Then we'll now click on hinge both ends. Where is it? Both ends hinge. So we'll click on it, then we'll now click on apply to the selected beam. So we'll now click on escape. So if you look now, we are having hinge here, we're having hinge here. So next, I want to apply hinge to all my I direction. So I'll click on this. This is I. This one definitely here will be J. So I will not bother looking at this point. So I'll hold my control key. This one I will not. This is I, but we're having a cantilever here, so I'll not hinge here. So this is I'll hinge it. This one is I, but I'll not hinge it because we're having a cantilever. This one is I, but remember we have already done this as a cantilever, as a simply supported beam. So I'll not hinge it again. If you hinge it again in form of I, that means it will only hinge here. Like that one you did for both ends will undo, and then it will only here will be done. So I'll leave it. I have done this. Then I have selected this. This is a simple. This is a Okay, this is a simple supporter. This is a simple supporter. So I'll not hinge. Remember, I'm hinging only I. So let me come and shake. I is downward. So this is a simple. This is a simple. I'll not touch it. Then I'll hold my shift key. Hold this I. I don't know whether you understand it, but if you're not understanding, you can just do it one after the other. Then I also hold my shift key. Click on this I because here is I. If you look at it, here is I. So I'll also this is a simple supporter. So I'll not touch it. Then I'll come here. Hold my shift key. Click on this I. Yes, I think we are through. So let's shake I. Remember, this side is I, so I'm having one here. Here it has a cantilever, so no. Yes, cantilever. It has a cantilever. No, this is a simple supported. This is a simple supported. Simple supported. So in terms of vertical, simple supported. Simple supported. Yes, this is my I. This is simple supported. Simple supported. Simple supported. This is my I. So I'll just right click and then click on hinge update on that beam air condition. I'll now click on hinge at left. That's the I members. Then I'll click it. Click on the apply enter me. So if you zoom well now, look at this IN. It has been hinged. Look at also this IN. It has been hinged. Look at this IN. It has been hinged. Look at this IN. It has been hinged. So the next one we'll be doing now is for J. So I'll come and click on this point. Then I'll also this J. I'll click here. Hold my shift key. So this is also J. I'll hold my shift key. Click here. So this one is also J. I'll hold my shift key. Click here. This is a simple supported, so I will not touch it. This is a simple supported, this is a simple supported, and this is a simple supported. I'll come to the vertical. Simple, simple, simple. So this is my J. I'll hold my shift key. So remember, I've done here as I, so I won't do it again. And this beam now, this one now is continuous, so we will not be hinging here and here. Then okay, this one is a simple supported, this one is simple supported. So I'll hinge here as my J, and then I'll also hinge here as my J. This is a simple supported. Then I'll now right click, then now click on update. Sorry, I'll then click on update beam end condition. Then let me hinge my J, applying to the selected beam. So once and through hinging my beams, remember hinging your beam will help you save cost. If you do not hinge your beam, you'll not be able to save cost, because if I do not hinge here now, like for example, if I do not hinge here now, ProtaStructure will be giving me something like y, let me say something like 5y16 or 3y20, but since I've hinged here, ProtaStructure will be giving me a normal reinforcement which is something like 2y16 and so. But if you do not hinge it, you are not saving cost, because ProtaStructure will be providing higher reinforcement, because what it means is that there is a moment at this point, and two, ProtaStructure must surely design to counter that moment. I don't know whether I've explained this beam hinging for you very well. Right now, what I want to do is that I want to see my 3D view of this my modeling. So I'll come here, click on view, right click, then I'll now click on 3D physical model. I'll click on it. I'll wait for it to load. So this is my 3D physical model. If you can see it now. So this is my 3D physical model. So right now, what we'll be doing is to let's go and insert the next story. That is the first floor. Let's go and insert our first floor. So I'll come back to plan. Once I come back to plan, I'll come to this building setup and then come to story and then click on it. Then click on insert story. Once I click on insert story, number of story will now be 2, because this one now is our first story according to ProtaStructure. So number of story will now be 2. The insert height, the height should still be 300. Then I'll now click generate members from the selected story. I'll check this, then I'll now click on OK. I'll now say yes. I'll now allow this to generate member from the previous story. So this is what it's doing. So this is my story 2 now. Let's go to our 3D view and see. So you can see it. I can see it. Yes. So but you should note that in this 3D view, you should know that now this point, these are our first floor. Then this point now is our roof level, and to we'll cover this place with zinc. That's our aluminium roofing sheet. So I need to delete this slab because we'll be using aluminium roofing sheet. So I'll select this, hold my control key, select. But if this is taking your time, you can just come here and you can just come to this story 2. You can just double click on this story 2. Once you then click on slabs. Once you click on slab, hold this, then hold your shift key to this extreme, then right click and then click on delete, then click on OK. Yes, so we have deleted everything. But don't forget what I told you initially. I told you initially that the minimum beam depth is 300. Yes, the minimum beam depth is 300. But what we are, and two, then we now have our slab depth of 150 added to it, summing it up to 450. But what we are having here is a beam of 450. But we want to be using the minimum depth of beam, which is what, 300. So in order to convert all these things to 300, what I'll do is that I'll come to this story 2. I'll then click on beam, right click, then I'll now come RC beam table. I'll click on it. So once I click on it, a dialog box will appear here. This is the depth of the beam. I'll click on this depth and then click on this person icon. Then I'll change this to 300, which is the minimum beam depth, because there is no longer slab added to this beam again. So I'll click on OK. So everything here will change to 300 and then click on close. So if you can see, we have reduced this. Make sure that you do this to save cost. Remember, first, our main priority is safety, and our next priority is to save cost. That's to be economical in our design and not to waste our client's money.
If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you.
But if you can remember, in our ProtaStructure, sorry, in our AutoCAD, when we are doing our structural framing, we have that some columns will terminate at the ground floor. Yes, we have that some column will terminate at the ground floor. We have that some column will terminate at the ground floor, and we have new columns emerging at the second floor. So let's go back to our plan view. So this is the story 2 now. So let's go back to story 1. We'll be going back to story 1. So remember, at story 1, we'll be having cantilevers. These cantilevers will be pulling off from our modeling. We'll be having all these cantilevers at this story 1. So I'll input this cantilever now. So remember, I'll input this cantilever now. So what I will just do now is that I'll come to my slab, go to modeling, I'll come under my slab, click on slab, I'll allow this dialog box to come out. Okay, I'll click on slab, then this dialog box will appear now. So I'll change this to 150. Yes, then I'll now come and select this type 12. This type 12 slab is for cantilevers. I'll select it for cantilevers. So I'll select this 150. Then concrete cover, I'll still leave it as this. Then under loading, remember I've explained this, so I'm using 1.5, and here I'll right click. I've explained it. Roof load, no roof load, because we don't have adverse weather condition here. There's no snow around here. So at cantilever, then the length of my cantilever. Okay, let's shake. Let's go back to ProtaStructure and shake. So let's go back to let's go back to AutoCAD and shake. So we want to know the depth of my cantilever. So my cantilever, that's from here to here. I'm having it as 450 for this one. I'll also right click. From here to here, I'm having it as 600. Okay, and then I'll check again from here to here, 600. So I'm having 600, then 450. So let me go back to my ProtaStructure. I'll go back to my ProtaStructure. So I'll input 450 first. Then what I'll do now, I'll now come and click here, from here to from this point to this point. I will now bring it out. I'm having this. So this is what I'm having. As you can see, this is what I'm having. Then I'll now right click on this thing again. I'll right click on it. I'll right click on it, the same thing, but I'll now come here to bring out its property, and then come here, change the length to be 600. That's what we're having in our AutoCAD from our textural plan. So this is what we'll be having. Then I'll also connect from here to here, bring it out. This is what we'll be having, and also connect from here to here, bring it out. This is what we'll be having, and also connect from here to here, bring it out. This is what we'll be having. So let's go back to AutoCAD again and shake this dimension for these ones. So I'm having that from here to here is 300, and also I'm having that this side, I think that all sides is 300, is still 300. So I'll go back to my AutoCAD, so to my ProtaStructure. I'll just double click on this cantilever to bring out this property. I'll double click on it to bring out this property. So I'll just come to this point and change it to 300. Then I'll come from here to here. I'll pull it out from here to here. I'll pull it out, and then from here to here. Hey, mistake, sorry. I'll just click on undo. Then I'm having that from here to here. I'll pull it out. So it's complete now. I'll then close. So this is what I'm having. Let's go to our 3D view. So this is my 3D. This is my 3D view. And remember, this is my 3D view. But don't forget, we have that. We saw in our modeling, we saw in doing our structural framing, we saw that this column will go, this column will go, these two columns will go, and then at the back we'll be having that this column will go, this will go, and this will go. Let's go back to our AutoCAD so you see it. So look at it. We'll have that this column, this column, and this column. Then we go, and then we'll now introduce new columns. So let's go back to our ProtaStructure. So I'll go back to my plan view. I want to go back to story one. So as story one, okay, sorry, I want to go to story two. As story two, we'll be having that this column, this column, this column, and this. I will delete them because they will go. Yes, I'll click on yes. So this column, they will go. Then since this column will go, we'll be having a new column that will be emerging from this place. But I want to click, I want that my plan to appear here. Look at what I'll do. I'll come here, I'll go to external reference drawing, and then this number of story now, I'll change it to 2. I'll change it to 2. So it will start appearing in this my second story. So let's wait for it. Okay, yes, it's not appearing in this second story because if you can see now, this is that our cantilever line. Yes, it's not appearing. This is that our cantilever line. As maybe you can remember, we have not seen this cantilever line before, and also look at this our cantilever line. And if you go back to story one, you see it will no longer be there. Okay, it has been covered by this. So now, right now, we are in story two. Let's just go back to our story two. What we will do now to model, because we have to move this beam to this point, this beam to this point, this beam to this point, all this beam to this point, even this. So for us to move this beam to this point, what we'll be doing is that we'll be creating a new axis on this line. So I'll just click on this, right click, and then click on offset axis. Once I click on offset, I'll just come and place it here. So this is the reason why I modeled this line in my AutoCAD, so I can easily place it, because as me I do not have this line now, what I'll be doing is that I'll offset this thing 300, offset this thing 500, offset here 600. For me it will take time, so I'll just offset and just come and place it at this point. So right now I'll double click on this line, I'll check, I'll remove this bulb, and then click on hide hidden axis, and then click on update. So this is it. So this is a grid line. So the same thing, I'll offset and place it here. So this is the reason why I found this boundary in AutoCAD, so that it will be easy for me to model it here in ProtaStructure. So I'll right click and then click on offset axis. I know this video is taking long, but the reason why I'm doing it is for you to understand everything, understand the basis and the governing principle in reinforced concrete design. I'll also click on update, because if I don't explain all these things, I don't think you really understand. Sorry, I'll not click on close. I don't think you really understand the governing principle in reinforced concrete design. So that's why I'm taking my time to explain every single thing. So pardon with me if this video is taking too much time. But if the video is taking time, you can increase the speed of the video, so it will be faster for you. Yes, if the video is taking time, you can increase the speed of the video, so it will be faster for you. So right now, this is that my cantilever. See my cantilever from here, here, and I've replaced them with a grid line. The same thing, I'll come and do the same thing to this point. I'll replace these cantilevers with grid line. I'll place it here. Then since I've selected this, I'll right click on property, and I will check off these boxes, and I'll click on hidden axis. I'll click on update. I'll then close. I'll then right click on this. Sorry, I'll right click on this, copy it, click on offset axis, then I'll place it at this point. Once I will escape, I'll right click again, click on property, because this one is already selected. I will double click to remove this circular thing, and then update, and then close. So okay, let me also I'll right click again, offset axis, then I will place it at this point. So yes, it's already a hidden axis, so no more need to hidden those things again. So right now, what we'll be doing, this is our story 2. So this is our story 2. What we'll do now is to move all this beam to this point, move this beam to this point, move this beam to this point. So you can either move this beam to this point, or you introduce a new beam. So me, I want to go by introducing a new beam. So I'll double click on this beam to select its property. So I'll then click that I'm having a beam running from here to sorry, remember we said that we'll be introducing a new columns here. So let me first of all introduce those columns. So I'm having a new column at this. So I'm having a new column at this point. Yes, but if you can remember, that column now should be inside. Let me escape. This column now, this column now, like, let me right click. I'll right click. So I'll show you how this column should be. I'll click on property. I'll then click on here. This column should be like this. So I'll click on this and then click on update. Yes, to bring it in. So it will be inside this grid line. So it will be inside this grid line to bring it in. So I will deselect, and then I'll double click on this column again. Then place a column here. So once I place a column, I'll come here, change the property. See, this is the property that we should be having. I'll update it. Yes. Then I'll come here again, paste a column here. Then I'll come here. This is the property that we should be having. Sorry, I placed it wrongly. So let me do control. Okay, don't worry. I'll delete it. I'll place it here. I believe this is the correct point. Wait, let me check. Oh, sorry, is this extreme one that is the correct point? I will see delete this one better. Sorry. Then this should be the I'll click. So this should be the correct positioning. I'll click on update. Yes. So I'll delete this is a mistake, and I'll also sorry, hold my control key. Then I'll right click. I'll click on delete. I'll click on okay. So I've deleted this. So this is what I should be having. And a column should and a beam will now run through and connect all of them. So I'll double click on this. I'll double click on this. So we should be having a beam. Sorry, I did not place it correctly. Not pressing. Okay, yeah, I see. Okay, I want to press. Okay, I want to have this beam at this point of grid line. So we should be having a beam running from here to here. But if you can see now, this beam is not in alignment. Yes, this beam is not in alignment, and it's not. It should this edge should lap with the grid line. This edge now should lap with that our grid line. So what we'll do now is that we'll come here, then we'll come and check which one is it. I think it will be this. Then I'll draw up, click on sorry, I'll click on update. Yes, so this grid now is now lapping with the grid, and if you see now, this point is now lapping together. Then this beam now will also continue from here to sorry, I should have introduced. Let me escape. I should have introduced this column because this column will be serving as a cantilever. So I should have introduced a beam here, pull it out, because this beam now will be acting as a cantilever. It will carry this beam that will run through here. Yes, it will carry this beam that will run through here. So I would say escape, double click on this to pick its property. Then I'll move from this point to this point. Yes. The edge is aligning with this grid line, so it's still okay. To this point, yes. Then to this point, yes. Then to it will now terminate here. But if you see now, this is our grid line. Let me escape. This is our grid line, and the edge is moving away. It should move inside. So I'll come here. I'll select this, then click on update. Yes, it now suits in. Hope you are understanding, because this is how you now model. So since I've done all this, I'll right click on this, hold my shift key, hold my shift key, hold my shift key. I'll delete all these things. This one too, I'll also delete this one, and then introduce a new pin that will run from here to this point. So I'll also hold this, and then I click on delete. Then I'll click on OK. Then I'll double click on this beam. So this beam now, after this we'll go and see what we have done using the software ProtaStructure. So this is what I'm having now. So this is what I'm having. Let's go and see the 3D view. Let's go and see the 3D view. Let me turn off all these axes. So this will be a clear drawing. I'll come to display. I'll come to layer. I'll turn off grid line. Turn off my ghost axis, plain definition, and text. So I'll be having a clean drawing. So if you see now, let's check what we have done. Yes, so this is it. If you can see now, so this is it. I'll be seeing it. This is the model. Make sure you should not make mistake in your modeling, no, because if you make mistake in your model, that means you'll be having errors in your design. And so because if you make mistake in your model, that means your load will not be transferred accurately. That means you'll be having mistake in your design. It's not like the software will not design it well, but it's designing the wrong thing. Yes, so you have to model your this thing. You have to do your modeling well. You have to take time, model it, understand the structure. So right now, the next thing that we're going to do now is that we'll introduce a beam here. Because ProtaStructure, if you leave it like this, ProtaStructure will not run any analysis if a column is resting on a slab. But for if the slab is less than 1 meter, if the cantilever is less than 1 meter, in real life, a column can rest on it. Or in real life design, a column can rest on the slab. But ProtaStructure will not allow you to rest any column on a slab. ProtaStructure has it that all columns must be rested on top of a beam. All columns must rest on a beam. So since that rule that ProtaStructure have, I'll introduce a beam here, and a beam here. Let me go back to story one. Don't worry. Once I go back to do it, you understand. So let me turn on my grid line and every single thing. Let me turn them on. I'll then come to modeling again. Then I'll come to my plan. I'll go back to story one. So this is my story one. I'll double click on it. So yes, this is my story one. So what I'm trying to say is that I will introduce a beam here, and I'll also introduce a beam here, and I'll also introduce a beam here to carry that column. So don't worry, let me just introduce, then we'll now go back. So I'll double click on this to pick its property. I'll double click on this to pick its property. But right now, I want the depth of my beam to be the depth of my slab, so that this beam now I want to introduce it so that it will not be showing in the building. This is for aesthetics, because if someone looks on, if after constructing this building and someone is seeing a beam running from here to here, it will no longer be that beautiful, it will no longer be fine again. The aesthetics will drop, like it will no longer be pleasing to the eyes. So for that reason, I would like to make my beam there to be 150. Yes, to be 150. Remember, I told you that in real life, this slab can carry a column. Any cantilever that is not more than 1 meter can carry a real column. Yes, but since ProtaStructure doesn't allow a column to rest on a slab, that is why I'm introducing this beam. So if I'm introducing this beam, I will introduce it as a hidden beam. A hidden beam is just a beam that is hidden inside the slab. So that's why I'm using the depth of my beam to be 150, because I want it to be a hidden beam. A hidden beam can also, you can also call it slab stiffener. Yes, that it stiffens the slab, it make it more stronger. So you can either call it a hidden beam or a slab stiffener. So in this, that's what I want to introduce here. So I want to introduce this from, I've changed the depth to 150. I want to introduce it from here to here. So yes, it's a cantilever, but we'll just leave it like that. Then here I'm having this, I will also introduce it. Hey, let me double click on it to select its property again. Yes, then I'm having from here to here. So what I will do now is that I will hinge the both ends of these beams that I've introduced now. Reason why I am hinging the both ends of this beam is because, remember, I told you initially that if not that ProtaStructure made it as a rule that you cannot rest a column on a slab, I would have rested this column on this slab, because in real life it's obtainable, it's achievable. But ProtaStructure have made it as a rule that I cannot rest a column on a slab. So that is why I introduced this beam. So if I introduce this beam, I want to now hinge it, because I know normally I shouldn't have introduced this beam, because if I do not hinge it, ProtaStructure will be providing higher moment for this beam. Like if you not hinge it, you can just, or maybe on your own, you can just, as you are doing this, you just don't hinge it, you see that this beam will fail. Yes, because you did not hinge it, because moment on it to be high. So I like to hinge it, because I know in real life I will not really input this beam. So I would like to hinge it. I'll hold my, but in construction I'll just input it as a hidden beam more. But I want to hinge it because I know it will see sustain. I don't really know that you understand what I'm explaining, but I will just want to hinge it. I'll come to it and click on and click on hinge, both end hinge, because if I don't hinge both of them, this beam will surely fail, because the moment on it to be high. So to reduce the moment of this beam, I have to hinge it, knowing the fact that I could have rested this column on top of this slab, but ProtaStructure doesn't permit it. So since ProtaStructure doesn't permit it, and I introduce a beam, then and I hinge that beam, so that I'll be having 2y16 here. If you do not hinge this beam, I bet you must surely increase the depth of this beam to 450. ProtaStructure will demand it to keep on failing till you increase the depth to 450. So I now hinged it to be having 2y16 and at a depth of 150. Thank you. So these are the things. So let me go back to my 3D view so you see what I've done. So as you can see, if you see that is you so this one doing construction, this one will be trimmed off. So if you see that this is the beam, is not showing. If you see that is in alignment with the slab depth. So we are through with this front modeling. So the next part we are going to model now. We're almost through with our with our modeling. The next part we are going to model now is this part. That's remember in our architectural plan, let's go back. Let's go to our architectural plan. So in our architectural plan, see this column stopped at this ground floor, it not continue. So let's go back. Remember, you can get this CAD file and practice. Get this CAD file and practice. Remember, this CAD file comes with the architectural plan, and also I've done the structural detailing for you in case you are working on, in case after your modeling, analysis, and design, you want to carry out your detailing, you can reference this CAD file. You can easily reference it at any point you are confused. You can make reference to it. So get this CAD file. The link is in the description below, and it is also pinned at the comment section. Get it and practice. Remember, practice makes what perfect. And to master anything, you master anything through repetition. That's through practice. So get this CAD file and practice on your own. It will definitely help you as a structural engineer. So let me go back to ProtaStructure. So this column and I'll hold my control key. I will delete both of them because they terminated at the ground floor. So I'll delete both of them. I'll click on OK. Then I'll then come to my plan again. Go to my story 2. So this is my story 2. So yes, no, go to my, I'm not yet on story 2. So this is my story 2. Remember, this is our new grid, and that means we'll be having a beam from here. A beam will now run from here to here to here. Don't worry, you now after we'll go to the modeling, so you understand why I ran a beam here, here, here. So, don't worry, let's just go. You understand? Let's just model. So I'll double click on this thing, on this beam. I'll run a beam from here to here. But remember, the edge of this beam should align with this. So I'll just come here, click on this, and then click on this, and then click on update. It's not aligning, so it's good. So this one should run from here to this point. If you see it's moving out, it's not inside. So I'll also click here, click on this extreme, click on update. It's not aligning, so it's good. We are good to go. And then click on this one. So we are good to go. So at this point now, I have to delete this, hold my control key, select this, and also select this. Then I click, I will then delete this. I'll click on OK. So since you have deleted this, that means we have to introduce a new beam that will run from here to here. Yes, we have to. Okay, yes, okay. See, we have to introduce a new beam that will run from here to here, and also a beam that will run from here to here. But I would not like a beam to run from here to here, because if this beam should run from here to here, that means it will be serving as a cantilever, and to that cantilever will be carrying a point road, which is this beam, and another point road, which is this beam. So for that, anyway, this is a roof beam, so I think it will be able to carry it. But I don't really want that. So for that, I want to introduce a column here, to minimize, because if I introduce a column here, that means that means this beam now will no longer be a cantilever. So what I'll do now, I'll right click, in which I told you structural design is totally dependent on the engineer. So I'll place a column here. So if you say I've placed a column here, that cantilever sign have gone. So I'll then now come, I'll then double click on this to select its property. I'll now introduce and I say new beam crossing over other beam. Do you want to split it? I'll say no, I don't want to split it. I'll explain what it means. I'll say no, I don't want to split it. What it means is that if you say yes, you want to split it, that means what it means that if you say yes, you want to split it, that means this beam will now run from here to here and stop, then continue again from here to this point. But no, that means if you do it like that, I don't think this beam will no longer be the one carrying this. So I want this thing to be a straight beam. So it will be that it is carrying this secondary beam. So that's why I say that they should not split it for me. So that this will run from here to here and this will carry this. Because if they split it, that means this beam is no longer carrying this. Do you understand? Yes, this is the ideology. So you have to understand what you are modeling and what you are doing. So we are through with the modeling. So I said that we'll go to 3D view. So you understand why I modeled this beam here. So let me go and explain it to you now. So if you can see now, the reason why we model this beam is because so we'll be having a roof. Remember, this is the former beam, and remember we have a cantilever. So if we do not model this beam, that means our roof will not be covering this cantilever. So for our roof to cover this cantilever, we have to model this beam and delete the previous one. Do you understand? I don't know whether you understand, but I believe that you understand. Yes, I believe that you understand. So at this point we are through with everything concerning our modeling. So this is what we are. Let me turn off everything, so you'll be seeing our modeling well. The next thing is to apply our wall load. So that's the next one we're going to do. And after our wall load, we'll come to the end of this video and continue next time. Sorry, let me click on escape. So this is what we are having now. This is what we have achieved so far. And I hope and I believe that you are understanding our lecture. So this is what we have achieved so far. So the next thing now is to input our wall load. So I'll click on layer again, turn on my axis. Remember, if you do not turn on your axis, if you want to model anything, it will not model. So that once you start modeling and it's not modeling, don't be surprised. Hey, what's wrong? You check whether your axis is being turned on, because if you turn it off, and try to model anything, it will not model. So right now, let me go back to. Remember, I'll go back to story one because it has this story one that will be applying our wall load. So I'll go back to story one. I'll double click. So this is the story one. Then what I'll do now is that I will come here, right click on this. I'll right click and click on edit load. Once you edit load, the dialog box, then it will not take us where we will input our wall load details. So I'll click on edit load. Once this dialog box appears, what we want to apply here is wall load. So this is for point load, full uniform load. So we'll come to wall load. This is what we want to apply. So we'll click on it. So this dialog box will appear. Then you come to this point and choose user define. Yes, so user define. Then if you want to put in windows and the rest, from here you put it. But me, I don't like putting windows and the rest because I want to design as what condition. So I don't normally like putting windows and the rest. So if you want to apply wall unit weight, so okay, so this is it now. This is wall unit weight. So 1 unit weight, your 1 unit weight, for 1 unit weight, okay, for 1 unit weight, we'll be having that. Okay, let me explain 1 unit weight for you. So for 225 by 225, sorry, for 225 block wall, each 1 unit weight is 2.87. That's the 1 unit weight of a 225 block wall. 2.87. But you know that after placing your block wall, we will do plastering. Yes, so we'll plaster both the front and the back. So the unit weight of plastering is 0.3. Of that plaster, the unit weight, that's the sand and the mortar, the unit weight is 0.3. So until you know, it will be 0.3, we'll be doing front and back. So it will be 0.3 plus 0.3, so which is now 0.6. That's the unit weight of the mortar and sand for front and back of the block wall. So let's now sum everything up now. So we'll get the unit weight of the block we'll be using. So in summing it up, we'll be having that the unit weight of block is 2.87. That's 225 by 225 block wall. That's 9 inches block wall. Each unit weight is 2.57. Then the unit weight of plaster, that is the sand and the mortar, is 0.3. We'll be having front and back, which is now 0.3 plus 0.3. We'll be having 0.6. Then 0.6 plus 2.87, you can press to your calculator, you now be having 3.47. 0.6 plus 2.87, we're having 3.47. So we'll come here and input our unit weight to be 3.47. So this is our unit weight. So at this point now, they're asking us what is the height of our block wall. What is the height of our block wall? So the height of our block wall is 2.7 meters. 2.7 meters, that's the height of our block wall. 2.7 meters. Let me explain it to you. Sorry, is in millimeter, so it's 2700. Since the unit is in millimeter, so it's 2700. Let me explain it to you. You know that if you check our architectural plan, the height of story 1 is 3 meters. Okay, let me just click on insert and then go to the modeling and show you. So the thickness of our block, we're using the thickness of block of 225 by 225. So I'll click on 225 by 225. Don't click on insert. Just come here and click on this. You have applied it. Then I click on OK. Yes, so these are block wall. But let me come to the 3D view and explain how I got that 2700. So remember, the height of our story building is 3 meters. That's the first floor. That is from this slab now, from the top of this slab to the end of here. This is our story height to the end of this beam, which is what? 3 meters. And remember, the block wall will start from the top of this, will start from the top of this beam, that's the top of this slab, and end at the below, at end here below this beam. While the height level is from this slab to this height here to the top of this beam. So remember, in our wall load, we'll do 3,000. That is the height of this story from this slab to this top here, minus this beam depth, which is 300. If you now do 3,000 minus 3,000 minus 300, we'll be having 2,700. So that's how I got this 2,700, that I use my wall load height. So right now, what we'll now do is that, see, this is what we now have here. We will now come and click on, we will now apply wall load to all these beams wherever we are having wall load. So I'll just click on this. Sorry. So I'll just come here. Okay, I'll click on this. Right click on copy load. I'll say okay. So I've copied this load now. Then I'll be having this wall load here. I'll hold my control key. I'll be having this wall load here. Hold my control key. Okay, let me just select everything. Let me select everything here. Hold my shift key. Select everything. Then okay, let me allow it to select. Then I'll now hold my control key and deselect the beams I don't want them to select. I don't want it to select this beam, so I'll not be having higher load on this. And I don't also remember, if you apply wall load here, that means you are applying wall load on the room. Let's go and check. So look at it. If you apply wall load there, this is the second floor. If you apply wall load there, look at it. That means you're applying wall here. So we'll apply line load. Don't worry, you see what I will do. So let me come back to my ProtaStructure. Let me hold my shift key and this. Let me hold my control key and deselect this. I'll deselect this. I'll deselect this. Sorry, hey, I shouldn't have deselected this, and also this too has wall load. Yes, it's just okay. After I apply that wall load personally, I'll deselect this. I'll also deselect this. Remember, this is staircase. There's no wall load at the entrance of this staircase, so I'll deselect it. And remember, this is my story building. This is my sit out. There's no wall load here. I will deselect it. There's wall load here, but I'll still apply it after. I think we are through. After, I will still apply this wall load. So there's no wall load here. Yes, after I'll say apply this wall load because there's wall load there. So okay, let's go and check set to know whether are we having wall load here and here. Let's check. So we'll not be doing guesswork. So if you can see, yes, we're having wall load here and here. So we are still on track. So after I apply wall load to this. So right now I'll then now click on, you can either come here. If you're using to ProtaStructure 2025, you can just come here and click on paste load, or you just right click and click on paste load. So yes, I'm through. Yeah. Yeah. So remember, we mistakenly read this. So I'll come here and click on paste load. That thing I told you. So we have that from here to here, we'll be having wall load on this. So I'll just click from here to here, there is wall load. Why from here to here is the sit out veranda, so there's no wall load. So I'll click on this, come here and click on insert wall by dragging. I'll click on this, then I'll now from here to here, this is where I want wall load to be. So I'm through. So I've, yes, this is what I'm having. So I've applied wall load to this, but don't forget, here we'll be having block wall. We'll be having a block wall here. Oh, sorry, let me delete this wall load. Delete road. And there's no wall load there. Okay. So I have to, here is okay now. So remember, here now at this edge, there is block wall along this edge. So, but we cannot apply block wall here. What to now apply here is line load. Line load. So I'll now come to my loading. Come here and click on point and line load. Come here and click on line load. So what is the magnitude of that load? So to get the magnitude of this load, what we do is the height of the block wall times the unit weight of block wall. Or look at another way you can get it. Or you just come here, right click on edit road. The dialog box will appear. You click on this. So you click on this. So look at it. Once we inputted this at 3.47 and 2700 millimeter, it automatically calculated our wall load for us, like our unit load of the wall for us. Look at it here. Average load is now 9.369, which is this times this. But first of all, convert this into meter. Well, that's 2.7 meter times 3.47 kilometer per kilonewton per meter square. So if you multiply both of them, this is the, so this is the load they are asking us to apply. This is the load we are going to apply in form of line load. That's 9.3, but I'll just call it 9.4. So I'll just come here, click on OK. So then I will come back again under my loading. I'll click on line load. That's 9.4. Don't forget, under line load here, I'll click on 9.4. So 9.4. I'll then come here at this edge, apply my load from here to here. Apply my load from here to okay, yeah, is it? We are still on the track from here to here. Then apply my load from here to here. Then apply my load from here to here. Yes, so this is what we'll be having. But don't forget, this one now, here is no longer block wall. Here is not handrail. We'll be having handrail here. So for handrail, I'll just like to use the unit weight of 1. I'll just like to use 1. This is not block wall. This is handrail. So so if you use 9.4, you are overloading this slab. So I'll also have this. Hope you understand this. So I'll now close. Let's go to our 3D view. So our 3D view, this is what we'll be having. This is that line load applied in form of wall. Then this is the slab load. This is the handrail. If you can see, it's very, very small. It's because we have already applied this line load before. So this one is 9 point something. This one is 1 point something. So that this one is 1.0. So that's why it's very, very small. And at this point, what we'll be doing next, okay, let's go back to our model. At this point, what we'll be doing next is to arrange this thing to be ready for analysis and design. So next thing that we'll be doing next is that let's go to building set out. Under story, we want to indicate our foundation depth. I'll come to option, I'll come to insert, sorry, not insert story, cancel. I'll come to option, come to edit story. So at edit story now, I want my foundation depth from the design report. The foundation depth should be 1200. So this is the foundation depth that I'm having. Then from here, the height of, look at it now, the height of my story, I'm having it as well 300 3 meter, which is okay, which is what I have in my architectural plan. Then if you look at it, they say this is imposed load reduction, but this is not really necessary here because imposed load reduction is used in high-rise building. Because you know, in high-rise, something like, let me say 10-story building. In 10-story building, maybe say in the 10th floor, in that 10th floor. 10th floor might not always be used. Maybe when you're using 10th floor, yeah, when 10th floor is in use, the ninth floor won't be in use. So we do apply imposed load reduction in high-rise building to automatically reduce the load. You just come here and click on apply, but that one, this is beyond the scope of this, because this is just a duplex design. But just know that this imposed load design is for high-rise building where you want to reduce load, because in high-rise building our aim is to reduce load coming down. So if you want to reduce load, the things that you can do is that you can use, instead of using solid slab, you can change your slab to waffle or flat slab, because waffle and flat slab have a lower weight, or a lower load, or any of them. So, or you can, instead of using block walls, you can be using partition walls. Let me say when you get to study 6 and so 7, you can be using partition walls instead of using block walls. And so this is our way to reduce building. And also after doing those things, you now come and apply this imposed load reduction. But this is beyond the scope of this lesson, so let's just stick to this. So we are through with everything we're having here. Then click on OK. So I'll just click on yes. So after I've edited my height and everything, next thing to do now is to edit this text. Next thing to do now, okay, I'll be this story one. Next thing to do now is to arrange the text of this thing now. Look at, I'm having bin 1, bin 2, yes, bin 3 is okay. So here should be bin 4, but I'm having bin 8. This here should be bin 4. Okay, so this one should be bin 4, bin 5, bin 6. So I want to arrange the text, even the column. I'm having column 1, column 2, column 3, column 4 is okay, column 5, okay, column test is okay. But I want to arrange the beam test and the slab test. So in terms of detailing, I can easily detail it. So to arrange them, I'll just come to review to arrange the test. Don't worry, you see, understand what I'm doing now. I'll arrange the test. Okay, let me see something. If you are seeing, look at, after 1, 2, 3, I'm now having, okay, here is 9, 8, 7, 6. Here is now 5. You see, it's not even arranged. Here is now 10, 26. But let me go arrange it so it will be easily. So I can easily. So once it comes to detailing, it will be easy for me. So I've already done axis before. I won't check axis again. I'll just check all these ones. Share wall. I'll just check all of them. I'll just come here and click on OK. So so if you look at it now, I'm having one. I'm having, okay, this one is 1, 2, 3, 4, 5, 6 is now well arranged. 6, 7, 8, 9, 10, 11, 12, 13. So it's now well arranged. That's the reason for arranging our pin, so that once it comes to detailing, I'll be faster in my detailing. So this is the main reason I do arrange. Then after, next thing I will do is I want to arrange the lettering of this. If you can see, it's inside the block, so I'll like it to be outside the block, and I'll not like all this 225 by 225 to be showing. So I'll just come to setting. These are all my personal settings. I will come to setting. Under setting, I'll come to Rabe. I'll come to Rabe. Then this, I want it to be outside. I just click on it. If you just click on it, I want it to be outside. So it's not outside. I'll leave it. Then in this one, I'll click on hide. I like it to hide it. Then click on OK. So let's go back. Okay, I'll click on OK. So if you see that I'm no longer having 225 by 225, I'm just having C1 and 2. This is placed outside. So these are all the settings I normally like to have. Then next thing now is to go to analysis, to go and do building model check. You can look at it here. I want to do building model check to make sure that I'm not having any error in my analysis. So you can look at the modeling again. Let me turn off the grid line so you see the modeling very well. Let's go to display. Let's turn off everything so you really see and appreciate what we have done so far. Yes, so these are the things I'm having. I've been seeing our modeling now. Clean and neat. Beautiful. Fine. Clean and neat. Yes. We have done a very good job. So let me turn on all my layers again. So next thing now is building model check. Yeah, building model check. So if you want to do building model check, we'll go to review. We'll click on building model check. We'll now click on start. So after our building model check, we are seeing that we are having 2 errors. So let's go and correct that error. We are seeing that we are having 2 errors. So what we are seeing here is that first error is that story 1 slab 17 is too small, has a very small area. Slab 17, but this is not a major error. So let's, but we will still and check. Slab 17 is having a very small area. So this is our first area. The next one is that story 1, S9 and S8 are overlapping. So both of them 17, S9 and S8. I'll just click on cruise. So I'll just come here. Story 1, S9 and S8. To easily locate it, I'll just come to slab, just click on S8. So this is this. So they say S8 and S9. So this is my S8, and also that means I. He said they are overlapping. S9 and S8 are overlapping. That means I inputted double slab here. I mistakenly inputted two slab here. So this is the reason why you should be doing your building model analysis. So I'll just right click and delete one. Delete. Yes. You see, I've deleted one. Okay. You not delete. Sorry, let me delete it again. Right click. Okay, I did. I right click delete. I have deleted one. Yes, I've deleted one. As you can see. So this is the reason why you should do your building model check. Yes, to know whether everything is correct. See, I mistakenly inputted, and to assuming I went on to do analysis, you see that all these beams they will be failing because load from two slab is coming to them. A load from slab 8 and slab 9 will be coming to them because these two slab are applied on this. So this is the reason why you should do your building model check. Next one is that S17 is too small. Look at the S17. They said yes, it's too small, but we cannot do anything about it. So therefore we will ignore that error. Then we ignore that error because we cannot do anything. We cannot increase this slab, so we'll ignore it. But we have done this one. We have deleted this. So let's go and run the building analysis again to be sure that we are up to date. So we are still having one error, and the error is that, where is the error? Is that and the error is that story 1 slab 17 has a very small area. We have said that we cannot do anything on this, so I'll just click on close. So right now, let me say something. If you can remember, in story 2, we did not do anything like fixed end moment, fixed end moment, summation of moment is equal to 0. The reason why we did not do it is because I know that it will pass. Like I've done a lot of design, and two, I know that since I've not been doing fixed end moment, like I've always been getting 2y16. So that's why I not bother doing it. Even the application of parapet road, I not so bother applying it because I know I'll still be getting 2y16. Okay, in fact, let's do the one of parapet road. Let's just apply a block wall of height 1 meter. So you see that also after design that it will stay pass. So let's just apply it. I'll click on it. I'll then right click. I'll go to edit road. Once this dialog box appears, I'll come to wall load. I'll come and change this my wall height. I'll change it my wall height to 100 to 1 meter. I'll then click here. I'll then click on OK. I'll click on OK. Yes, so I've applied this. Let's see it in our 3D view. So look at it in our 3D view. So this is just my parapet road. I'm using this block as my parapet road. So I'll now paste it around the perimeters of this my building. So I'll hold my control key and select them all. So I selected column. Let me click on escape. So I'll hold my control key and then select everything, all the outer beams where I'll be having parapet. So I'll select them. Yeah, I selected them. I'll select them. Then I'll deselect this. I'll also come here, select this. Then don't worry, let's continue first. I'll select this and I'll also select this. So I've selected the whole perimeter. Let me hold my shift key. Okay, I've deselected this. So I'll just try paste road. I'll then paste my road. Click on escape. If you see they have pasted road round it. Okay, not paste road here. I'll click on this and click on paste road. So then at this point I'll do drag road. So I'll just come and click on insert wall road by dragging. I'll move from here to here. Is okay. Then also for insert road by dragging, I'll move from here to, so I'll click on insert wall by dragging. I'll move from here to this point. So it's okay. So I'll see this one. So I'll click on insert wall by dragging, then move from here to here. So right now I've applied all this parapet road. So look at it in our 3D view. So this is it in our 3D view. Okay, not apply here, I'll say apply it here. So this is it in our 3D view. This is it. Let me apply that one I missed out on. Look at it. I'll click on insert road by dragging. So I will select this. I'll click on insert wall by dragging from here to here. So this is what I'm having. Let's go and see it in our 3D view.
If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you.
So this is what we're having at 3D view. Let me turn off everything so you see it. But I know normally, I know if I'm doing a personal design, I will not apply this roof. I will not apply this parapet roof because I know even after I finish applying it, my design will still be passing. I'll still be having 2 by 16 in the beams. So that's why I don't normally bother applying it. But I just apply this because this is a tutorial, so people will follow on. Yes, so this is what we're having now. See how clear our model is. Yes, so let's go back and continue. Let's turn on our layers back. Let's turn them on. We're going to turn on every single thing. Yes, this is what we're having now. This is what we're having. And we have come to the end of this lecture. Remember, you can get the cut file of this architectural plan in the link on the description below and practice on your own. Remember, the CAD file comes with both architectural plan and the structural design or the structural drawing of this architectural building. So you get to learn. Even when you're making mistake, you can reference the structural drawing and be up to date. But first, there's something I forgot to mention in our previous video. That is to include the height of the finished floor level. So I'll come to story operation. I'll go to edit. So this is it. First story bottom level. First story bottom level. What it means is that the difference between your finished ground floor and finished floor level. Like that's the difference between your soil and the difference in height between your soil and that's your ground soil and your floor and your finished floor. That's where you place your terrazzo and the rest. So that's different. And we're using it as 450. So that's what I forgot to include in our last section. So I click on OK. Then it will open. But I'll then go to analysis and design. But before I go to analysis and design, I'll first of all turn on my grid lines and everything. So to turn it on, I'll come to display, I'll come to layer, I'll turn on my axis, I'll turn on my ghost axis, turn on my plane definition, and turn on my text. So after I've done all this, the next thing to do now is to go and carry out the analysis. So I'll come and click on analysis tab. Click on analysis tab, then I'll click on building analysis. I'll click on building analysis. Once I click on building analysis, this dialog box will appear. So first thing to do first is to come and edit my material. So I'll come click on edit material. So for the concrete grade I would like to be using here, I'll just click on it. So I would like to be using 20. Now look at it, compressive strength of 20 Newton per meter. So this is what I like to be using. I'll click on apply to all members. I'll click on OK. Then come over to the steel grade. So this is the steel grade. I'll click on it. The steel grade I would like to be using here is grade 460. I like to be using grade 460. I'll also click on apply to all member. But look at rebar diameter. I'll come here, click on edit to edit my rebar diameter. So for this my column, I like to be using 16. So I like to be using 16. This is it. Then for my shear wall, okay, initially I don't have any shear wall, so I'll just save it. But for my beam, I like to use 16 for my beam. Yes, I like to use 16. For my slab, I like to use 12. Yes, for my slab. Then if there is any checked one, you uncheck it and just only see. Some people will do, let them choose between 16 and the 20. But me, I normally like choosing only 16 because if I finish choosing 16 and 20, doing interactive design, those ones that software gave me as 20, I'll still convert them to 16. So for me, there's no need of doing 16 and 20, or else I'm doing all this high-rise design that I'll not be doing 16 and 20 because I know that the client will be able to afford 20. So if I'm doing a duplex, if I'm carrying out a duplex design now, I'm having Y20 in my reinforcement. If I submit my structural detailing or my BOQ, you see the client might not even look at my work set because he's seeing Y20, saying but other duplexes are Y16. So that's why I don't normally like checking Y20. I'll just check only Y16. This one I'll check only Y16 in terms of the beam. Then we don't have shear wall. In terms of the slab, I'll check only Y12. Then in the rib slab, we don't have rib slab here. Coming to the foundation, I'll check only Y16 as my foundation. Then coming to the ring, I'll also check only Y10 as my ring. Then this one is for shear wall. These things are for shear wall. So I don't have shear wall in this design. So I'll just leave it. I'll not check it. So I'll just click on OK. Then I'll click on apply to all members. I'll click on Okay, so I'm through with this. Next thing to do now, I'll come to foundation. Click on foundation. I'll still want my compressive strength of concrete to be 20 20 25. That's 20. I'll click on OK. Yeah, not click on apply to all members, but I have only one member here. Then in terms of sand, I'm having sand, clay, and this. But I've gotten my this thing, my soil bearing capacity to be 120, and to that 120 in that place, what we have is sand. So I'll just leave it. I'll still leave it as sand. Then I'll come over to this grade of steel for foundation. So the yield strength I like to be using is steel 460, and yeah, I'll still click on apply to all members. If you click on edit, it still has the setting that we have done before, so I would want you to carry out the reinforcement setting again. So I'll click on OK and still click on OK. Then coming over to this link, I'll choose my strength to be 460 too. I don't want 500. I'll click on apply to all members, then click on OK. So after this, I'll click on OK. Then after I'm through, after once I'm done with here, then you now come. Assuming I have wind road, I would have applied wind road, but this is a small structure. So assuming I can shake the height, look at the height we're having after story two, having 6.42. Look at if you can see it after story two, we're having 6.45. So it's not even up to 10 meter. But if it's up to 10 meter, we'll apply wind load. But since it's not up to 10 meter, I will not bother applying wind load. So I'll go straight to my analysis. So I'll click on, we have done building model check before in our previous video. Then now click on building analysis. So in this building analysis, in this building analysis, I'll check this is the design. Some people might just want to first of all run the building analysis, then after they will now come back and then do the design of column and beam. But me, I want to do all of them together because this is just a small building. But if I'm having a very high building, I like to first of all run the analysis, but let me not bother you with that. So I'll just click on column. So once it's after running the analysis, it will design my column for me, it will design my stair for me. So I can click on reselect bar. Reselect bar is in case where is in the places where I have up to more than where I've selected more than one type of bar. For example, in column, as me in column, I selected Y16 and Y20 I'll do the reselect bar. And also another time but sorry, but if you have done your building analysis before, if you have designed it before and I have done interactive design, don't worry, I'll see what interactive design is, and you have done interactive design and some fails and you want to rerun your and you want to redesign it again, don't click on this, because if you click on this, all your efforts, like after you have done your interactive design, all your effort will be in vain because it will scatter all of them. So if you have done interactive design before, after you have designed it and you want to redesign it again, don't click on this again. So as me having steel member, I'll click on steel member design check, but I don't have any steel member here, so I'll just click on building design. So we wait for it to carry out the design of our structure. So as if this is kind of design of the structure, don't forget you can still get the architectural or plan and practice on your own. It comes together with you can still get the CAD file and practice on your own, because practice make perfect. The more you practice, the more you get to learn what I'm explaining here, and the more you get to experience it practically. And two, don't forget the architectural CAD file comes with the architectural plan and also the structural detailing. So in case once you are doing some certain things and you encounter any issue once detailing, you can easily reference back that structural detailing for more clarity. So that's why I also include the structural drawing in the architectural CAD file, so you can get it in the link below. It's in the description and it's also pinned at the comment section. So our beam is designing now. So I think you have done column design, but I not see it. Column design has been done. So this is the beam reinforcement design. So let's wait for it. It's almost true. So this one here is almost true. So this is it. Yes. If your relative story drift fails, what it means is that you have to increase the size of your column, or you increase the number of your column. That's if you are seeing bad here. That's if it fails in direction one and in direction two. What it means is that you go and increase the number of your column, or you increase the size of your column, one of them. So after seeing this, the next thing to do is that I'll come and click on OK. So we now click on OK. So we click on OK. So we click on close. So look at it. It's not check building analysis. It is marked good. So let's go and view our analytical model. To view our analytical model, we'll come to view. We'll click on view. Then when I click, then we'll now select building analysis model. That's we want to view our analytical model. We'll click on building analysis model. So like let's wait for it to load. For us to see our analytical model. Look at it, building analysis model is showing up. It's showing up everything. Yeah, so this is our building analytical model. Yeah, this is all where it was performing the building analysis. But we can go to this solid model. Let's wait for it. So this solid model is telling us on how is showing us how the force is being transferred. Yes, it's showing us how the force is being transferred. For example, this one on blue is one carrying the highest load. Look at it. It's carrying a load of 193 kilonewton. Look at it. Why this one's on the edges? Why this column on the edges? They are carrying a lower load. Look at it from yellow downwards and green downwards. Look at it, 94, 98, 78 to even to even 13.1. So the one on edges, they are carrying a lower load. So the reason why these ones at the center are carrying higher load is because we have because they are all surrounded. It is being surrounded by slab all around. Yeah, it is being surrounded by slab all around, so it is carrying load in all direction. Why these ones at the edges, they are just carrying load in just this side. They are carrying load just this side. They are not carrying load this side because there is no slab this side, so they are not carrying a lesser load. Why these ones at the center, they are carrying a larger load. So that means we are seeing that what the software did or what the software design is accurate. So this is what you're having. So let's go back to I can just come here and delete this building analysis model since we have checked it. Let's wait for it to go. It will bring us back to our model. Then we'll now come to design status. Let's go and check our design status to know what we are having. So I'll click on visual interrogation. Then I'll now scroll down to design status. I'll then click on OK. If you can see now, we did a nice job. So if you can see now, those on green passed. So if you can see now, most of our, in fact, if I say most or all of them, they are all on green. That means they all passed. And also, if you have anyone on red color, that means it failed. But we are not having anyone on red color. Then if you have anyone on on orange, that means it's expired analysis. Why? If you have anyone on white, it's not designed. For example, look at our slabs. Our slab, they are all on white. The reason is because we have not yet designed our slab. But these are the things we'll do in this video. So right, and if you get your drawing, if after design and you're seeing it like this, all of them green, don't just leave it like that and go. Do interactive design. So let's come to our story plan. So okay, we'll turn on the design status again. So click on design status, we click on OK. So let's go to story one. We'll double click. So we are now in story one. So remember, even if it passed, even if all of them should pass, do your interactive design. You must carry it out because sometimes the software might over reinforce. So if it's over reinforced, you know how to go about it. So I click on section design. So on section design, let's wait for it to open. Then we will now check. I'm having 2x16, 2x16 is okay, 2x16, 2x16, so it's okay. Everything is okay. So since everything is okay, 2x16, then you can come here, click to see the bending moment diagram. Look at it. These are bending moment diagram. This is that I'm telling you. If assuming this is that I was telling you about hinging. Let me explain. This is that I was telling you about hinging. Assuming you did not hinge, assuming we didn't hinge this our beam now, this thing will not start at 0. It will start at here. That means there will be moments here. It will start like this, then go up. See, we did not hinge here and we're having moments. But since we hinge here, this thing started from 0. But if you did not hinge it, it will start from here. And then in design, ProtaStructure will provide reinforcement to counter this moment. And where if he provides reinforcement to counter this moment, that means it's giving you that means you'll be over designing. That means you are no longer economical in your design. So these are the reason why I say you must hinge your member so that it will start from 0 and it will start from 0. So that means we hinge there and we hinge there. So that's why having starting from 0. But assuming I will not just hinge one. So you people will just see the difference. But assuming it not hinge one now, you see it will start from here and gone down. That means there is moment here. That means ProtaStructure will provide for the moment. And also see now, there is moment here and there is moment here. Reason is because we did not hinge these members. We did not hinge here. That's why we're having moment here, and that's accurate. There should be moment here. We should be having hugging moments. And so let's go and check. Let's check. Let me close this now and check back the reinforcement that they provide. You see, we'll be having higher reinforcement here compared to the reinforcement we are having here. So we'll be having not higher reinforcement, higher area of steel required than the area of steel required for this section. So let me just close it. If you can see the area of steel we're having here, 56.67. The area of steel we're having here, because we hinged here. That's why they are giving us more area of steel. But look at the area of steel we're having here, 199 and 178.6. And also look at the area of steel we're having here. So you see, if you hinge your members, you'll be having smaller area of steel. Look at it, area of steel. You're having smaller area of steel. So that's the advantage of hinging your member. And also, assuming we're having higher load coming to this now, assuming higher load was coming to this structure, assuming something like this is a commercial building, you see now here will be something like that 3y16, and this like if you not hinge it, will be having that kind of 3y16. So that's why I say hinge your beams. Make sure you hinge it to save cost, to reduce the moment coming on it, because assuming with no hinge it, here will also be here will be like something like this 119. So that's the advantage of hinging your member. You can say you can say see here that with no hinge that is also 2y16, but don't forget this is a residential building. Assuming now you're working on commercial building, now you see now this thing will be failing. But anyway, don't worry, let's continue. You will still understand. So let's click on OK. So this is how, okay, remember once we clicked here, he brought out this one, and this one, because this is a continuous beam. So once you click here, it will bring out this whole beam. So if we click here, why it will bring out this whole beam. So let's click here, let's do the interactive design of this. I even forgot to mention something. I'll come to section design. So if you are doing the interactive design, don't forget, if your area, if here now, if this is the area of stay required, this is the area of stay required, then these ones now are the area of stay provided. This is the area of stay required. This one is the area of stay provided. I am not seeing where utility ratio is here, because I could have explained utility ratio, but don't worry, once we go to the code room, I will explain utility ratio, so for you to understand. So this is the area of stay required. This is the area of stay provided. So make sure that your area of stay provided is not less than 100 millimeter square. Make sure that it's not less than 100 millimeter square. Reason is because, remember, but anyway, it depends on your country. If you are not this United States, the UK, Canada, where you are sure that they don't tamper with standard, or they don't tamper with quality, yes, you can go with what the software gives you. But if you are something country like Nigeria or this African country, don't make sure that it's not less than 100, because you know that in Nigeria, Y16 is no longer Y16. Y16 might just be, in all this African country, Y16 might just be Y14 or even Y13. And also the yield strength that you are telling us 460, it might no longer be 460, it might be 420, 430, or even 410. So to counter this lack of to counter that, that's why I say make sure that this your area of stay, this area of stay provided, that's extra area of stay provided, is not less than 100, to counter that. So ensure that in your design. So here you are not having any of them less than 100. Please ensure that, to avoid building collapse, because these are some of the things that causes building collapse. It's not that the engineer did not do a job, it's just that the company that are producing all this reinforcement, they are tampering with quality. They are not giving us the exact quality. So in order for us to prevent the collapse of the building, will do this. Also, another thing that you can do to prevent collapse of building is, inside, ensure that you accurately wrap your reinforcement. But we shall do that one more once we come to detailing. Ensure that you accurately wrap your reinforcement, in the sense that lapping length should be 50 times 50. Lapping length is 50D. That's 50 times the diameter of bar. Look at it. These ones are okay. 2x16, 2x16. So I'll click on OK. So lapping length, let me just be checking and explain what I'm explaining. So lapping length is 50 times the diameter of bar. So make sure that once at any time, if you are wrapping, that you wrap 50 times diameter of bar. For example, if you're wrapping, if it's Y12, 50 times 12 is what? 16. Sorry, is 600. That means your wrapping length should be 600 mm. So let's continue. Let's keep on shaking. But due to the length of this video, I don't think I will shake everything. I think I've shaked enough. Maybe if you get the CAD file in the description below, once you are practicing, you cannot check all of them. But due to the length of this video, I will not check all of them. So, but most of them are giving me 2y16. So it's okay. I'll come here, section design, 2y. Okay, see this one. I be seeing this one. This one is giving me 55. So I'll increase this to 3. I'll increase this to 3, because I will not want that I won't even give him again. I want it to be above 100 to prevent collapse. So I will increase it to 3. Thank you. So I'll click on OK. So this is how you just do everything. Let me go to story 2. Let me do small in story 2. I'll double click. Then we'll just do few in story 2, and then continue. Then on your own, make sure you go through everything. So we're having ABC. This is the reason why I told you that I don't normally like applying all these hinges on top of the roof. On our roof section. Look what they're having. Like the look at what you're having. Area of stay required is 0.9 point. So it's too small. So me, I don't normally apply hinges on my roof load. And also look at the area of stay provided. The area of stay provided is 300 and something. Why in story 1 we're having that area of stay provided is even 200 and something. So the area of stay here is even more. So that's why I told you normally. But you'll be applying your wall load. That's for your parapet load. Just be applying it on your design, so that once you are submitting your brand to whoever, so once the person looks at it, you know that you know what you are doing. So I'll just shake one more, because we still have much thing to do in this video. So I'll just shake one more. So I'll click on this one is far above, so I'll just click on OK. So now come over to column. So let me go back to story 1. We'll come over to column. Yeah, we come over to column. So I'll just pick random columns. I'll not shake all everything. So I'll click on this, right click on section design, the same thing on column. So let's wait for it. Let's wait for it. So you are seeing you're having 2 to 5 by 2 to 5, 460. You see, utility ratio, our utility ratio here is 0.2. So now let me explain what utility ratio is all about. Utility ratio is the ratio of reinforcement required to reinforcement supply. That's utility ratio. The ratio, or you can just say reinforcement required divided by reinforcement provided. So for example, as we are having that the reinforcement required is 240 and we provide 200, you see, if you do 240 divided by 200, I'll be having 1.2. That means the utility ratio will be 1.2. And if this utility ratio is more than 1, that means that your column member will fail. If it is more than 1, even in terms of being 1, if your utility ratio is more than 1, it will fail. Reason is because utility ratio is the area of steel required divided by area of steel provided. For example, if it is required that we should if this section requires 240 newton per millimeter square area of steel and I provide 200, if you do 240 divided by 200, I'll be having 1.2, so it will fail. But if the area of steel required is 240 and I provide 250, I'll be having 0 point something, so it will pass. So that means in all of design, ensure that your utility ratio is more than 1. But this one passed, so it's okay. So I'll just pick random color. I'll just pick 5 in numbers. So I've done 1. I'll just pick, okay, let me pick the center ones. I'll just pick 5 in numbers. I'll just pick five numbers. So look at it, utility ratio 0.1, so it's okay. 0.19 is okay. Let me pick this one. I'll click on section design. So I'm having that utility ratio is 0.4, is okay. It's passing. So I'll just click on random, but on your own you can check all of them. So I'm also having, look at it, utility ratio 0.19. So let me go over to story 2. So look at it, utility section. So we're having the wait, you see the utility ratio is 0.14, so it's still okay. It passed. Let's check another one. I'll just check 2 here. Let's check this one, section design. So we're having, look at it, it passed. Utility ratio 0.2, so it's okay. So we are through with everything now. So what we are going to do now, let's come over to our 3D view. So this is what we're having. This is what we're having. So this is what we're having. See, everything passed, everything passed, everything passed. So the next thing to do now is that we will design our slab. Yes, we will design our slab. So I'll come over to plan view. That's this one is now under slab design. I'll come over to slab view, plan view. Then I'll come over to, I'll click on story 1. Then I'll come and click on more there. I'll click on slab strip. I'll click on slab strip. So under S direction, I'm using analytical strip. As we are doing being left and slab design, that's when we'll be using this FE strip, but we are not doing that. So right now, if you can see now, this will pick our boundary. So picking our boundary, this one means this one now stands for this, like we're having a beam, then in front of it is slab. Look at it, a beam, then in front slab. This one now stands for cantilever, somewhere like this for cantilever. Then this one now stands for a continuous beam. That's, for example, inside here, as we want to do is slab C from here to here. But don't worry, as we are doing it, you understand. So at start, I want to first of all do here. At start, I'm having cantilever, so I'll click on this. And at the end, I'm also having cantilever. I'll click on this. Do you understand? Then I'll now I'll just come close to it. Hold my control key to strengthen the line, and then click like this. Yeah, it has designed. So if you look at it, I'm having T12 at 250 spacing, so it's okay. Then I'll come, okay, look at this one. Let me do this one. I'll not do everything, so I'll look at this one. I'll do this one. So this one, I start. Look at it. I start. I'm having this, which is this, a beam, then slab, which is this. Then at the end, I'm having slab and beam. So look at it, slab and beam. So I'll click on this. Then I'll now zoom. Blue way, right? Remember, this is for S direction. Then place it here. So this is what we're having. So in this case now, okay, look at it now. In this, let's do now for this case now. This one now, for this is now Y direction. I said I will not do everything to save time. So this is now Y direction. This is Y direction. So if you look at this one, I'm having cantilever and slab. So I'll click on this. This cantilever and slab. I'll click on this. Why here? I'm having slab. I'm having slab beam. So look at it, slab and beam ending. So I'll click on this. I'll go from here to hold my control key to here. It has designed this in y direction. Then let me just say, as me, I want to design only for this, only for this. Okay, let me do the whole of this. So for here is cantilever. I'll click on cantilever, and here is slab. So I'll click on this boundary one. So I'll pick here and hold my control key to here. So this is what I'm having. But after, you can then continue all okay, look at this one. As me something like I want to design only inside here. So I'll come here and pick. Look, I'm having beam. I'll come here and pick beam. And also I'm having beam. I'll come here and pick beam. So I'll design only for this. Hold my control key. Hold my control key. So this is it. But I've not really designed everything. Let me control Z to undo. In your own, you do it accurately. But me, looking at, if you look at everything here, I'm having two eyes, T12, that's Y12 at 250 spacing, Y12 at 250 spacing, Y12 at 250 spacing, Y12 at 250 spacing. So me, in my own detailing, what I used to use is Y12 at 200 spacing. Reason is still what I told you concerning beam. I'll use Y12 at 200 spacing because most of the African countries, even the one even where I'm located country, which is Nigeria, most of our company, they tamper with quality. Yes, the steel strength, that's the yield strength of this Y12. The yield strength we assume to be 460, might be 410. Even the Y12 again might no longer be Y12, it might be Y10. So that's why in my design, to counter all these things, I'll now do Y12 at 200 spacing, even though that design gave me 250 spacing. For me, in all my slab, I'm using Y12 at 200. In all my slab, at least the space will be at least 200. So we have done this slab design, and we have done interactive design.
If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you.
Right now, we have come to the end of this tutorial. In our next video, we'll be doing our foundation design. Then after foundation design, we'll now export after our foundation design, we'll now extract our structural drawing in ProtaDetail. Then we'll now export it to AutoCAD. Then we'll now carry out our structural detailing. All these things will be done during the course of this video. So you get to learn everything. So right now we are through. Watch out for our next video. So having successfully designed our structure, next thing to do now is to come to this story level, which is foundation level. I'll double click on story 0. Yes, this is what I'm having. Let me turn on my grid line, let me turn on my axis and everything. So I'll come to display, I'll come to layer, I'll click on ghost axis, plane definition, and also test. So I've have everything turned on. So so I'm having this. We have already done the interactive design. We have carried out the interactive design. So I want to remove this design status. So I'll come over to display, come over to visual interrogation. I'll scroll up, click on none, and click on OK. So right now our aim is to design our foundation. But first, before I start designing your foundation, there are some settings that you need to do in ProtaStructure. So I'll come over to my setting tab. I'll click on it, allow it, let a dialog box will appear. I'll come over to foundation. So I'll come over to foundation. So once I appear here, so soil unit weight, generally soil unit weight is 18 kilonewton per cubic meter. So but I'm having that the allowable stress of my soil, allowable stress of soil is my own. In this case, that's soil bearing capacity. From the design report, from the soil report, I'm having it to be 120. Then you leave everything here as default. If you want to you can come and change this soil vertical subgrade coefficient. But before you change it, you should know that you should have a very good knowledge about this subgrade coefficient, because and if you want to get a very good knowledge of it, you can go to Joseph Boyce and get a very good knowledge of it. But if you don't know anything about it, you can just leave it at default. So we'll leave it at default for now. So we'll come over to ring concrete thickness. So this ring concrete thickness is just known as, is just serving as your grinding. That's your ring concrete, just like grinding. So in this case, I'll be using 50. I don't want to use 100. I'll be using 50, and I'll also be using 50. So I'll just leave this one as default because you are not carrying out strip foundation design here. Then the fourth part footing form. Me, I want it. I would like it to be square. I like it to be square. So I'll leave everything here the way it is. Then I'll come over to this side, leave it as default. Then I'm now having minimum footing width. That's the minimum width of your footing. I want to leave it at 1000. Then coming to minimum part base depth. So coming over to minimum part base depth, that's the depth of your foundation. Sorry, the depth of your footing. I would not like it to be 400. I would like to choose something like 250. I would like to be using 250. That's it, to be my minimum footing depth. Okay, fine. Let me use. I want 300. I want 300. So I'll go with 300 to be my minimum depth, minimum footing depth. Then coming over to maximum steel bar spacing, I'll leave it at 250. I'll leave it at 250. But I know, remember what I told you, that even me, even also in footing, since because of quality, I always like to go with the spacing of 200. So for that, I'll just do 200 because I know that 250 will pass. In fact, let me just leave it at 250. Then doing detailing, I will now use a spacing of 200. So coming over to size increment. Size increment, I'll still leave it at 100. Yes, I'll save it at 100. So both the depth increment, I'll save it at 100. What do you mean by size increment? For example, size increments, what it means is that assuming I'm to use scoring of 1200, and if 1200 fails, it will increase by 100, which that means the next column size they will provide for me is 1300. But if I should leave the size increment to be 50, that means if 1200 fails, the next column size they'll suggest to me is 1250. 1250. Yeah, so for me, I don't like all these 50 at the back. I always like it to be a whole number, like a complete whole number, 00. So I would like to be 100 size increment. Then concrete cover, I'll like my concrete cover to be 50 millimeter. Then come over to this, I'll just leave it at default. Then coming over to this point, uncheck this, use top bar. Don't use top bar in our path footing. We don't normally use top bar. The only time that we use top bar in path footing is if it is a combined path footing. If it is a combined path footing, that means that's what we'll be using top bar, because there will be moments. But if it is not a combined path footing, don't use top bar. But don't worry, we'll still explain this thing more later on. Then coming over to minimum steel bar. So me, I would like to be using steel bar of 16. Oh, it's true. Remember, I am doing our when we are editing material, I chose 16, but I'll go back and select 15. I'll go back and select 12 because I want to use the minimum steel bar of 12. I'll go back and select 12. So with all these things, I'll come here and click on OK. So once I click on OK, I'm here. Then I'll now come over to analysis again. Come over to building analysis. I want to edit my material. Come over to this point. I'll come over to foundation. So I'll shake, since I'm having sand there, I'll leave it here because from the report, from the soil report, the soil report says that it is sand, so I'll leave it here. So the foundations, the concrete strength of foundation, I would like to be using 20/25, which is 20 Newton per millimeter square. Then coming over to steel grade, I would still like to be using a steel grade of 460. Yes, it's still okay for me, 460. But I want to use my foundation. I want my foundation to be Y12. Sorry, Y12. Y12. Then if it fails, let it now go to Y16. I'll write the minimum to be Y12. Then if it fails, let it go over to Y16. I'll click on OK. I'll then click on OK, and then click on OK again. Then click on close. Then I'll now come over to my setting again. I want to increase. I'll come up to foundation. I would like to use minimum to be Y12, even for distribution. I would also like it to be Y12. Then I'll now come and click on OK. So right now, I've successfully done my settings and everything. Next thing now is to design the column. So to design my column, I'll just click on this. Once I click on it, I'll right click, then click on insert path footing. I'll click on insert path footing. I'll click on it and wait for it to be designed. So let's wait for it to be designed. It's coming up, it's loading. This thing is that it's designing this path footing. Yes, the dialog box will appear once it's true. Once it's true with the design. So look at it. Design is successful. So coming over, look at what we gave up at a depth of 300, which is what we choose as our minimum depth. I'm having a concrete cover to be 50. Yeah, I'm having the concrete cover of 50, which is what we choose. So this is what this is what the design gave us. So after design, I'm having that I should be having a square footing of 1400 millimeter. by 1400 millimeter. So I'll come over to this point if you want to see the 3D view. So coming over to this one, see it. So this is what I have. So if you see that it is not doubly reinforced, yes, it is not doubly reinforced because we unchecked that part of doubly reinforced. So it's not doubly reinforced. So as me you want to see your column load, this is where you will be seeing your column load. You come and click on column load in case you want to design it manually to verify what the software gave you. So you can come here and pick the load coming to this column and design it. Then come over to Rebar. So coming over to Rebar, assuming that it is a combined footing, assuming you're having a combined footing here now, we will now click on I will now click for you to add top reinforcement at in both directions. So let's zoom, see. So it has included a top reinforcement, but this is not a combined footing. So we'll uncheck this and we'll also uncheck this. But if it's a combined footing, it must have a top reinforcement. It is a must. It must have a top reinforcement for it not to fail. It must have a top reinforcement. Okay, let me just explain it like this. You know how Alright, I will start by first explaining the basics, which is why must the tension zone in every beam be reinforced. As we all know, if a uniform distributed load or even a point load is being applied to a beam, that beam will be subjected to tension and also subjected to compression. Look at it, the bottom part will be subjected to tension, while the top part will be subjected to compression. What do we mean by tension? We mean by tension in the sense that it will be stretched apart, and compression in the sense that they will be coming together. And as we all know, concrete beams or concrete in general is totally weak in tension. So because once it is being subjected to tension, it will stretch apart, and which will result to failure. So for that reason, in every beam we always reinforce the tension zone, because concrete is very weak in tensions, and once a beam is being subjected to any load, this tension zone is prone to failure. So that is why in all our beam we always reinforce our tension zone. Then coming over to a cantilever, as we have explained before, that concrete is very weak in tension. If this is a cantilever and we apply a load at the extreme, if you can see, the top part will not be the one in tension, while the bottom will not be the one in compression. In the sense that once we apply a load to this beam now, it is the top part that will be stretched out. And if the top part is stretched out, it's this stretched part that is not in tension. And if it is not properly reinforced, it will fail from this tension zone, because concrete is generally weak in tension and very good in compression. This compression zone will not fail, but as a result of this tension zone failing, it will not result in this compression zone also failing. So in other words, to counter this thing, in cantilevers we do provide reinforcement at the top portion, while in beam we do provide reinforcement at the bottom portion, but it is only applicable to simply supported beam. But in continuous beam, the support parts are being subjected to tension, but we'll still explain that later. But I just want you to understand that once it comes to a cantilever, the tension part is the one subjected to tension, and once it comes to a beam, that's simply supported beam, the bottom part is the one subjected to tension. And two, concrete is very weak in tension. That is why we always reinforce the tension zones. So let's now coming over to combined footing and isolated footing. So I'll explain using this diagram below. But first of all, let me explain combined footing before going over to isolated footing. So first, this is the footing base, which is this one on green color. Why this is the column, and two, this column is transferring its load to this footing base. And so look at this point load now. This point load means column. This point load is sent as this column. It is transferring its load to this footing base, which is this one on green color. Then we are having this uniform distributed load is the soil. It will try to resist the load that this column base is being transferred to it. So why this one now is just the way this footing base will deflect under this column load. That's this ones, and then this ones. It's just the way this footing base will deflect under this load. So let me explain it now. So if this column transfer its load to this beam will deflect like this, meaning that this top part will be under compression and this bottom part will be under tension, meaning that we'll have to reinforce this bottom part. Coming over to this point, the only load being applied to this footing base is this soil, which is this UDL. So this UDL will try to deflect this beam upward like this, meaning that this top part will now be under tension, while this bottom part will now be under compression. Take note, at this point now, this top part is under compression, while this top part is under compression, while this bottom part is under tension. Why at this point this top part is under tension and this bottom part is under compression, meaning that And meaning that within this portion, we would need to reinforce this top part. We need to reinforce this top part because it's this top part that is under tension. While coming over to this point now, this cooling load will cause this thing to deflate downward, meaning that this top part will be under compression and this bottom part will be under compression. So look at this is the bending moment diagram. This is the feedback diagram of this. Then this is the bending moment diagram of it. So that means we're having moment at the base, moment here, and also moment here. So for that reason, we will reinforce the bottom to counter for this moment, and we also reinforce the top to counter for this moment because this top part is the one under tension. And wherever we're having tension, that means we'll be having moment there because wherever we're having tension, we'll be having moment there. See here, the tension zone is the bottom. That's why we're having this tension zone. That's why we're having a moment here because the tension zone is at the bottom. So in this combined footing, we will reinforce the top zone to counter for this moment and reinforce the bottom zone to counter for this moment. While coming over to isolated footing. In isolated footing, this is the column. This thing is the column. This is the footing base. Why this is the soil serving as a UDL. So this is how this footing base will deflect once this column load is being applied to it, meaning that this bottom part will be subjected to tension and this top part will be subjected to compression. Meaning, remember, concrete is very weak in tension. We'll only reinforce this bottom area, leaving this top area. So this is the bending moment diagram. So if you see in isolated footing, there is no need to reinforce the top because the moment there is no moment on the top, there's no moment at the top, only at the bottom. So that's why we reinforce. That's why in isolated footing we reinforce the base, not the top. While in combined footing, we reinforce the base and the top too to counter for this moment.
Okay, let me just click on okay. Okay, we are through with the design. So I'll just come here and click on okay. So if you see now, this is what we're having. So coming over to the design of this, I'll just click on it, then click on insert path footing. I'll wait for it to design. Yeah, it's designing. So look at it, design completed. So I'm having this. Then if I also want to label it, I can just call it I can just call BT1. Yes, BT1 because this one is 1200. The other one I have is 1400. But normally for the labeling, I normally leave it for my detailing. Once I'm detailing, I will label everything once. I will not stop. I'll not bother myself labeling it here. So this is how you just do it for all your. This is how you do it for all your coding footing. Wait for it to design. This is what we are going to do throughout. Then we look out to having 1300 by this. Since we are not having combined footings, that means it is only single reinforced, not double reinforced. So let me come and do the ones this one. I click again. I'll do insert part footing. I'll do insert part footing. Let's wait for it to design. So this is what we're having now. Look at it, 1400. So say we click on OK. Let's wait for it to appear. Then we'll now click on this one again. Click on insert part footing. We'll click on insert path footing. Yeah, we'll click on insert path footing 1600. Yes, I think this is the column that we're having the highest load on. So let's go and check again. Let's click on OK. So let's check again. So you see that the part base provided for this one is 1600, which is very more. So let's go and check our analytical model again. I'll click on view and I click on building analytical model. I want to know whether is this column that we got that was carrying the highest load. So if you come now, look at it, is that column? Yeah, look at it. This column that is having, because we have said that the ones on blue, means that they are carrying a very high load. The load, look at, for example, this one's on blue, the load coming to it is 193 kilonewton. That's the load coming to it. Then the ones on lead, look at it, the load coming to it is 13.1 kilonewton. And to that, if you see, they are the ones on lead and the ones on lead and on orange, they are mostly placed at the edges. Yeah, because they are not really carrying slab on all direction. But these ones at the center, they are carrying slab on all direction. That's why the load coming to them is high. That's why their load is high. Look at it. And to this is the one we just designed now that we are getting there. The part base is 1600. If you see, the reason why the part base is 1600 is because the load coming to it is much. So let's go back to our story and finish up our design So I'll click on this, like click again, click on insert path footing. I'll click on insert path footing and wait for it to insert. Yes, so this is what we are having now. I'll click on OK. But right now, you can due to the length of this video, I will just pause and do everything. I will pause and do everything.
So right now we have successfully designed all our path footing. We have successfully designed all our path footing. So coming to the 3D view, we'll come to the 3D view. This is what we are having. This is what we are having. We have successfully designed them all. If you see, all of them are all on green. Means they have been designed and they are all passing. Also our slab, they are all on green. Mean that they have been designed and they are all passing. Even our columns and our beams. So at this point, what we'll be doing now is to export this to ProtaDetail. So to export this to ProtaDetail, what I'll come to drawings and report. Coming to drawings and report, I'll come and click on ProtaDetail. Then once I click on ProtaDetail, I'll allow it to load. It asks me, do you want to save the changes? I'll click on yes, I want it to save the changes. So I'll allow it to load. So while waiting for it to load, remember you can get the CAD file of the architectural plan used in this series of tutorial and practice on your own, because practice makes perfect. If you want to master anything, it's through practice and it's through repetition. It's through practice. The more you practice, the more you get to know. Remember, the architectural plan comes with the structural drawings. Yeah, in case after your designs, analysis and everything, after your design, I enter detailing. Once you encounter any challenge, you can easily reference the structural drawing that I did to be clarified on your issue. So right now, ProtaDetail is opening. Let's wait for it to finish up. Then we'll now extract our drawings. Or once it finishes, we'll now extract our drawings. So it's still loading. So yeah, it has opened. So this is the ProtaDetail interface. So you can come here and click on auto generate detail, or you can click on and start by creating a new drawing. So this is what I want. I click on start by creating a new drawing. So once I click on start by creating a new drawing, I'll first of all come to form plan. I'll right click. I want to, if I want to do one by one for foundation, for story one and for story two, you'll be doing it one by one. But in this case, I want to do everything at once. So I'll right click on draw floor plan. Once a dialog box will appear, then I'll just come and click on OK. I'll click on draw. So I'll now locate a point where I will draw it and then click. So I'm waiting for it. Let's wait for it to draw. So this is how we are going. This is what we are doing now. We are trying to get all our detailing. Then after, we'll now go to AutoCAD using stone bridge detailing template. I'll see introduce it in our next video and perfect our detailing. Then coming over, normally I don't normally like using, I don't normally extracting column, but let me just extract it for the sake of this video. So I'll come and click on this, right click on draw column application. I'll just click on OK. I'll then locate this point. I would like it to have the drawing at this point. Let's wait for it to draw. Let's wait for it. So this is the column application. Then you can come and click on column elevation, right click. You know, normally I don't like to draw column elevation, but due to this video I'll also do it. Click on draw, then click on this point. Yes, it will successfully draw my column elevations for me. Then I'll click on it again, right click, draw column schedule. I'll click on draw. I'll then click on any point. So this is the column schedule. Then I'll click on story beam elevation. In this one, I normally like drawing this one by one. I'll not like to click on this. No, I'll just right click on story for it to do only story one. So I'll right click. Don't click on draw beam elevation one by one. No, it will take your time. Just click on draw beam elevation. Then come and click here. Click on draw. Then you move up. Well, I would like you to draw it here. Yes. So this is what I'm having. Let's wait for it to draw up. It's loading. It's loading. Let's wait for it. Yeah, so it has given me the drawing successfully. Then I'll come and click on for story 2. I'll not click on draw one by one. I'll click on draw beam elevation. I'll click on draw. I'll like to place it by the side here. So let's wait for it to draw. It's generating the drawings. It's generating the drawings. So let's wait for it. Then after this, we will now come and do our path footing detail. So we are to we will now come over to path footing detail. We'll right click. We will not click on draw one by one. We'll just click on this one, draw path footing detail. We'll click on it. Then we'll click on draw. We'll now come and place it here. So let's wait for it to draw. So yeah, at this point, since we have been able to extract all our drawings, then we'll now export it to AutoCAD. We'll export it to AutoCAD. Then we'll click on here, right click on export. Once you click on export, you now come and click change directory. So this point, you now pick a place where you want to save your file. So me, I'll just pick anywhere. I want to save it here. So I'll click on here, click on OK. Once I click on OK, I'll now click on export. So it will now go. Look at it, it is saving. it is saving. So once it's through, it will take us to the place where we chose for it to be saved. Then from there, we'll now open it in AutoCAD interface. So let's wait for it. Yeah, it's loading. It's loading. Yes, so this is what we are having. So this is what we are having. Look at the drawing one, but you can rename your own. Then you now double click on it. Once you double click on it, yeah, it's opening on AutoCAD interface. So you will now see our drawing. Click continue opening the WG file. So let's wait for it to open. Let's wait for it to open. Then you now see your look at our whole drawing. So these are our whole drawing. So right now we have come to the end of this video. In our next video, we will be doing we'll be manually perfecting the details that the ProtaStructure have given us using this software AutoCAD, but we're making use of stone bridge detailing templates. But don't worry, in our next video I will get to introduce you to all this. So stay alert, because we will soon post our next video, so you learn more and get you and know more about engineering principle. So with this, I believe that you have learned a lot from this video. But don't forget, practice on your own. You can get the CAD file in the link in the description below, and the link is also pasted at the comment section.